Hello and welcome everyone to Rust Week, day 2 of the conference. Welcome!
Welcome, welcome, welcome.
Are we still awake? Or are we already awake, I might ask. It's, how many of hours sleep did we get? Like enough? Roughly? Maybe not, maybe not.
Did you get coffee? Yeah, nice
I
coffee?
hope we did, yeah. I just run on adrenaline. It also works. It also works quite well. Welcome everyone to the second day. I am your MC today. I'm your presenter. I'm Ida. You may know me from such things as Bevy, theater, if you know me really well, and being unemployed. So I'm available, and that will be the last time I do any self-promotion.
Hi, and I'm also your MC. My name is Wouter. I'm an embedded developer and also a board member of the Rust.nl Foundation. Some house rules and logistics. First, maybe.
Definitely.
We have organizers and volunteers in the yellow shirts. If you need anything, like, well, almost anything, you can just ask them and they will try to help you out. For example, if you have issues with accessibility around the venue, do not hesitate to ask them to help you around.
Also, please be mindful of each other and follow our code of conduct during the main event, but also related dinners, the unconference, and just be a nice person. That will go a long way in making this a very pleasant conference for everyone.
If you have any allergies, we have a special bar. It's called Rund. It's in the middle of the 3 bars. So it's basically on the left-hand side of the venue and then the second bar. There you can ask for anything specific to meet your dietary, how do you say this? Dietary
restrictions,
yes.
Or preferences too. Lastly, let's go over the agenda real quick. This is the main track. If you are confused and you wanted to go to the compiler track or like the Rust, what's it called today?
It's the applied Rust track.
It's the applied Rust track. You need to leave the room now. That's good, you're all in the right space. But yeah, the main track is here in Cinema 12, and the Rust project track is in Cinema 7, and Applied Rust is in Cinema 8.
Well, at the end, we'll also probably have a closing session here at the end. And after that, we'll have social drinks downstairs, same as yesterday.
Yes, and lastly, if you need Wi-Fi still, it's on the back of the badge. And I think that's most of the pre-flight checks. How's everyone doing?
I have a little poll I want to perform. Who here has never used Rust? Can you raise your hand? Like, I'm not very...
Yeah, we're being blinded by stage lighting here, but it's good.
Okay, so...
You kind of see it.
Who here has been using Rust for less than a year? I also don't see a lot of hands. Okay, so now I'm going to increase the time scale. So if you already had your hand up, you can put it down again. 1 to 2 years, 2 to 3 years, 3 to 5 years. I'm increasing it.
I think that's me. I think probably around me. I think.
5 to 7 years, 7 to 10 years, 10 to 12 years.
It's very old school.
12 to 15 years. Do we have? I see there. Longer than 15 years. Is there any hand? Can people point?
I don't see any.
I don't see any.
I think this is good. I think this means we don't have any time travelers in the audience.
That was actually the plan, to suss out if we have any time travelers.
No time travelers in this room. We obey the laws of physics.
Yeah. Well, actually, Rust is almost 20. It is 20 years now. So we should have gone further, but not necessary.
Anyway, I think that does it for us. So we have a whole range of wonderful speakers here today.
Yeah. Our first speaker is very topical. I read an article this week that there has been some changes to the Rust vulnerability mailing list, of the Linux vulnerability mailing list, due to a huge increase in new bug reports. So the next talk is going to be related to that, and very, very interesting. The next speaker is Greg Crow Hartman. He's a fellow at the Linux Foundation, responsible for stable Linux kernel releases, maintains USB driver core staging drivers and other parts of the Linux kernel, and is in charge of the Linux kernel CVE team. So give a big round of applause to Greg.
A warm welcome, yes.
Cool. Okay. Hi. Welcome. Thank you for having me. I am a kernel developer. I'm primarily a C developer, so I'm going to bore you with some C slides. I'm here to talk about untrusted data in Linux and how Rust is going to save us. And as mentioned, it's been a long month or two on the kernel security list. So I'm going to make even a more bold statement and say how you are going to save Linux. Sorry, it's all on you. This is my personal opinion. I do not reflect anybody else. I've been around in the Linux kernel security team since it started back in 2005. I have seen every single kernel security bug ever, and since then, and I've issued all the CVEs. We're doing 13 a day or something crazy. We are the #2 creator of CVEs in the world. We're not #1. WordPress is #1. But CVEs are weirdly weird on the kernel side, because any bug at our layer is a bug that could potentially be a problem to the world. But we also, because we're open source, like Rust is open source, you cannot dictate use. So we don't know how you're using Linux, so we have to be very careful and say, this could be a problem for you, check it out. And that's it. So that's why you see our huge number, because open source cannot know how you're actually being used, which is good. I'm not upset about that. So here's Linux, little basic primer. The kernel is below user space. Most traditional Rust code is written for user space programs. Memory safety kicks in, you crash. No problem, away you go. If the kernel crashes, you got a problem. Our goal of a kernel is to abstract away the hardware. So you're running your user space code for Linux, and then you don't care what's underneath you. You don't care if it's a Raspberry Pi, if it's a giant S390 mainframe, PowerPC, x86, you don't care. Our job is to hide all the bugs in the hardware and make it easy so that you just think everything is fine. So the kernel is interesting for a software project in that it's never going to be finished. Most software projects, you finish it, you meet the goals of what you want to do, and your development tapers off. The kernel doesn't stop because new hardware keeps coming, the world keeps changing, new things happen, so we keep needing to make this abstraction layer look the same for the past 25, 30 years, and for the next 30 years. And that's a different engineering task than just writing a kernel once. It's easy to write an operating system or a program once. It's really hard to make it work for a long period of time. And the kernel developers are good at this. We've been doing this for a long time. We're also huge. We got over 5,000 developers last year, at least 400 different companies. We haven't been keeping track too much recently. We've been busy with other things, but it's the largest open source project out there. And it's also one of the fastest moving one. This is our rate of change. Our rate of change years and years ago, 20 years ago, we thought was going too fast. We've been doing almost 9 changes an hour, 24 hours a day, 7 days a week for the past 20 years, which is insane if you think about it. And the changes are all through the whole tree. The whole kernel is all the hardware, all the device drivers, everything. But you only run a tiny subset. So the kernel is like 40 million lines of code. Your laptop runs 2.5 million lines of code. Your server runs 1.5. Servers are really simple. Your phone runs 5.5 million. Phones are most complex beasts out there. So, but that change is proportional to the whole kernel. The core of the kernel is 5% of that. 5% of those changes are for the core kernel. We have no problem rewriting the core kernel. We have no problem fixing things there. Again, 13 CVEs a day. We also have stable trees, and about 40 changes a day are going back to the stable trees, so it's a percentage of what's happening there. And then 13 of those, another smaller percentage, is actually security, considered a vulnerability. And we do a new release every 8 to 9 weeks. We've been doing that for 20 years. Time-based releases are very important. We're good at this. You can set your clock at it. You can look at the calendar. You know when things are going to be released. And also, if a feature comes in, we don't feel bad about saying wait till the next release because the windows are so short. It all works well. And there's a full talk on how I did this. I gave an interview with somebody up in Amsterdam not too long ago. Just Google that and you can see a whole long talk of how we do this type of stuff. And we also run the world. There was a talk yesterday, somebody said, who hasn't used Linux? And everybody's used Linux. It's also in the projector. Android, billions of devices. I joke, everything else is a rounding error. The server people don't like that. Chromebooks, #1 selling laptop for the past 20, 15 years. Linux, the year of the desktop, has happened and nobody noticed. All the Wi-Fi out, hotspots, cellular networks, those are all, everything. My washing machine. My most favorite, there's an automatic cow milking machine, runs Linux. Don't know why. All the chargers for cars, those are all Raspberry Pis running Linux. It's everywhere. All the air traffic control in Europe, if you flew into Europe, sorry, it's running Linux. So we're everywhere. We've taken over the world, nobody noticed. That was our plan. So let's see C code. Sorry. This is some C code. This is real code in the kernel. A couple years ago, turns out this is a bug. Compiles fine, runs fine, ran fine for like 15 years until somebody realized that, oops, we are dereferencing a pointer without checking that it really was successful. And there you have to fix it. Say, did we dereference it? Yes, it was an error, go to unlock. That was a vulnerability. This is C code. This is what we're used to, not forgetting to check things, forgetting to unwind error conditions, do that kind of stuff. And also goto, we use goto a lot in the kernel, not a problem. Goto error paths, cleans up nicely. And when we clean up, we unlock. We fix a lock and we return an error. That's great. Fix the bug, we move on, not a problem. That goto unlock. Sometimes we forget to unlock things. Another CVE. In the Zen code, again, this is a real bug fixed back in 2024. Go to fail remove. Fail remove actually does the unwinding of the lock. Otherwise, we were returning an error. We caught it properly, but we forgot to unlock. Very common C code. The majority of the bugs in the kernel are this tiny minor stuff. Error conditions aren't checked. Locks are forgot to unreleased. Memory's leaked. Vulnerability adds up over time, crash the kernel, away you go. This is what we live with in C. This is why we don't like it. So in C, we've been looking at what Rust can do. There's something in C, the newer versions of C, where we can add guards, and we can do automatic dereferencing of things when they go out of scope. So we added things for locks. So now we can say guard. Okay, we can add a guard here, and it said when this goes out of scope, the lock will be freed automatically by the compiler. Everybody's happy, we don't have to worry about that. Now, we're not going to go back and rewrite all the existing code, but new code going forward, we do patterns like this, and it works very well. Again, we can do this again. Return pointer, we can save pointers off, and if the pointer is an error, everything gets freed. Otherwise, we do a borrow checker and pass it off to the owner. We stole this from Rust. Thank you. It's a good idea. So if Rust disappeared tomorrow, we have cleaned up the C code in the kernel so much and took in the ideas, we thank you. You've made Linux better with it, just by existing. So I'm very thankful of that. So now we have that. We have C-scoped locks and allocators. And we've added this new code. It makes it harder for us to get it wrong. But most importantly, it makes the coding simpler. And we're very important about that. We have lots and lots of developers. We don't have as many reviewers and maintainers. We got about 700 maintainers. We got about 150 core maintainers. Review time is what we have the least of. Same thing with most open source projects. More developers than reviewers. It's a very common thing. We optimize for making code easy to review. And the scopes make it easy to review. We can review it. If I can review your code easier, I can glance at it and say, hey, look, you obviously got it right because you used that pattern. All is good. And less bugs. So it's both. Easier to review, less bugs, and it makes us happier. All a good idea. So let's look back at the original code. Here's that C code. If this is for our Bluetooth core. This is the core of the Bluetooth stack. Again, another bug in Bluetooth. If we were to rewrite this in Rust, here it is in Rust. The only difference, I show this talk to C programmers all the time. Rust code is not scary. It looks just like C code, except for that little question mark up there. If that question mark was not there, the compiler would stop. As you guys know, we have to check the return value. If we had not actually checked the return value, the compiler would say, no, you are doing something wrong. I want code that comes to me. If it builds, it's correct. And that's the best beauty of Rust. So with error return values, Rust gives me that for free. This function would return an error, pass it on up, and all would be good. The error handling, I don't have to do anything special. It built, I know it works. Error handling's proper. Same thing with locks. In the kernel, we have locks using Rust. The only way you can get access to inner pointers of structures is by grabbing that lock and releasing the lock automatically. The compiler does it. It's guarded, the lock happens, everything's happy. You just can't write code to access these values or these inner values without grabbing the lock. The compiler will not let you. This is good stuff. This is going to save us. Those two things, I don't know. 60% of the bugs in the kernel, right there. They're gone. Thank you. So if this happens at build time, not review time, don't make me, a maintainer who has to read your code, and say, oh, did you properly check that error value? Oh, did you properly grab the locks in the right spot? Rust gives us that for free. This is the best thing ever. Again, it meets all our requirements. It makes the coding simpler. As a developer, you catch it at build time, you know it's right. Reviewing me, it's easier. Less bugs, we're all happy, we can do more fun things. Very good. Because, again, we have more developers than maintainers. So, in summary, for this type of stuff, Rust makes reviewing code easier. If I see stuff that builds and doesn't break the build, we have bots. You send a patch to the kernel list, the bot will run it. If it breaks the build, it'll just report it right then. As a maintainer, I don't even worry about it again. I make sure the code actually builds. You have that in your CI systems for all of your other projects. We can enforce all this stuff today automatically for free with Rust. This is great. This is what sold me and a number of the core kernel maintainers on Rust in the first place. We're happy. If everything moves and migrates to Rust over time, great. You guys did a wonderful job. We're very, very happy. But that's not all. When I went to the first Rust for Linux conference that I was invited to, I was invited as I was having objections to the Rust. We have our own idea in the kernel of how we handle C objects and references, and Rust has its own idea of how it handles this type of stuff. And I was really worried about this bindings and this type of stuff. So I was sitting in a presentation by Daniela, who was talking about the driver core, I maintain the driver core, and I realized about 10 minutes in, this whole hour-long presentation was for me. But on that same side, we were seeing things like, he's like, here's all the work I had to go through to deal with the C code over here. So there was like hundreds of lines of Rust code to deal with 2 lines of C code. And our realization was, I can change the C code. We can change the C code to make the Rust code simpler. We have no problem changing both sides of this barrier. Let's do that. And over talking hours after that presentation, and then over drinks and food and months after that, we came to that realization, this is all going to work. We agree on how this model is going to work. And I will give Daniela and the other Linux Rust developers credit. It's actually better than I ever expected. The rules involved and how the traits and the interfaces are working for the driver core and the interaction with the C code in the kernel is going to make drivers simpler to write and harder to write wrong. It's a wonderful job. They've done a great, great job. But along those lines, we also have something in the kernel for bugs. The main problem of all bugs and all our things and the problem in the world is this. If you never remember anything else in my talk, just remember these 4 words. They came from Microsoft Security many, many years ago. They realized all input is evil. You have to validate all input. And in the kernel, we have special pointers. We have pointers that are called user data. And you have to copy them into the kernel because you have to do some memory transforms for some types of processors. And then you have a clean kernel pointer. Well, and then that kernel pointer and that kernel data disappears into the kernel type system, and we just pass around pointers all the time. And we forget that it really came from user space. It's hard to track that. So I came up with the idea, I've been talking about this for a long time, how about if we have a way to mark the data as untrusted when we get it? And Benoit, who's somewhere here, helped write this code. It's not merged yet, and there's a talk later today about some field projection stuff that's going to need to be doing it right. But we have something called untrusted. It's a type. Add it to the data, and every time you want to actually get access to this data, it's just a type, it's not actually code, it's going to hint to the compiler, you must go through validate before you actually access it. And when you review code that comes from the kernel, you look at these spots. You look at the spots where you copy data from user space to the kernel, and then it's hard tracking it after that. But here, everything's focused to one section of the code. You can see all the code that does the validation of the transformation from user space, untrusted data, to trusted data in one spot. And here's an example of this code. Somebody's already taken this and tried to write a driver for it, where we transfer a structure from user space into the kernel. I don't like this. I don't think this is good code. I can object to this, but I now know where to look. I know instantly, I can say, hey, let's look at where the untrusted data becomes trusted. They're doing some funky stuff. They're really not validating all the data that's in there. But now I can complain about this one point of code in the kernel. And I know where to review it, and I know it. It's just like unsafe. You know to spend special time and effort looking at that point in place. It's not spread out everywhere. This is good. We're reducing the scope for what we have to do. We're still working on this, how this is going to work, but you get the idea. Here they're just basically casting it away, and all is good. There's some other examples where they're trying to do some Endian conversions, but I think more work needs to be done there, but I can object to it on the technical grounds of with this code is that. But it's all sanitized. It's all in one spot. And this is what's going to really save us, because we don't trust data. We're getting so the model and the kernels, we don't even trust hardware. Hardware's full of bugs, but now you can have malicious hardware, and we're seeing more and more malicious hardware. Linux was written, and all operating systems were written with the assumption that we trust the hardware. Well, now we can't trust hardware. So how do we track this? If we add untrusted to the type of the data coming from the hardware, it's easy to realize where we need to check, where we need to validate the data properly. And that, I think, I'm going to make this unscientific quote. This is what's going to save Linux. The combination of all the other stuff and the untrusted data, I think, is going to get rid of 80% of all the CVEs we have. And that's a huge, huge number. We would not be number 2 in the world for CVEs, but that's a good thing. I'd be very happy. And this is why I really want to see Rust happen. Rust is going to evolve in the kernel over time. Some subsystems have said, hey, only new drivers for graphics should be written in Rust. We can see other drivers for other subsystems should only be written in Rust. And this is up to the maintainers and developers working together for this. But over time, we have now hit a critical mass that you can write really good drivers for all different types of subsystems in Rust, in Linux. I think over the next year or two, you will see this, and we will evolve. Linux is evolution. It's not intelligent design. We evolve over time, and over time, new drivers for new hardware come in. You'll start using that new hardware. The old drivers just won't get used anymore. Eventually, we'll delete them, as we do after about 20 years. But it'll happen. And then you'll just evolve and move, migrate slowly over time. There's code in the core of kernel that is Rust today. That's the first kernel Rust code was for when the kernel crashes, it'll display a QR code on the screen. That logic was written in Rust. Famously, it had a memory bug. It was given a buffer and a size of the buffer, and the Rust code never checked the size of the buffer. Could scribble all over memory because Rust can crash just as bad as C. You can do some pretty horrible things. Memory safety doesn't mean the same thing in the kernel. So infamously, the code for displaying a screen when the kernel was crashing could crash. Nobody really noticed it. It was fixed up properly. It was all good. But it is not a silver bullet. I don't want to tell people this is a silver bullet. Because again, this code compiles just fine. Runtime crashes, not a problem at all. And because when we crash, when we have an exception, we just reboot the machine, away it goes. But that is a vulnerability, because it's denial of service. People don't like that. So you're not getting access to other memory. You can't maybe exploit it. But again, it is a denial of service. So at the kernel level, crash is just as bad. It's in the kernel today. So we have 36 million lines of C, 113,000 lines of Rust. Most all of this is bindings. People say, oh, let's just write a driver in Rust. It'll be simple. It's off to the side. Well, drivers consume from the whole of the kernel. They consume of how they interface to this, the memory, to work queues, to locks, to everything else. So Alice and the other Rust for Linux developers have had to go and write bindings for everything in order to write a tiny driver in Rust. So there's been this whole infrastructure that's had to be added. We also don't like adding code to the kernel that isn't being used. So it's hard to add a binding for the C code to the Rust code unless you have a user for it. So it's a little bit of a chicken and the egg. We've had to bend that rule a little bit into places. But right now, we're just doing like portions of it. So we have a portions of the file handling, do what binder needed. And we have a portion of maybe what netlink is for network stuff because another little driver needed. We have a portion of like the MISC API because that's what needed it. And those will grow over time. We have a very, very tiny portion of USB nobody's using. I'll probably delete it. If you want to write a USB driver in Rust, talk to me. I'd like to actually get that working. So this is what we have today. It's growing. Android phones will be coming out hopefully soon, running all the Rust code and binder. So that's, again, billions of devices are going to be running Rust in Linux soon. This is all hard. This is, as you guys know, we do our development in public. So when we do our development in public, when we argue in public, people like writing articles about us arguing in public. I talk to lots of companies and they're like, oh, look all this division. I'm like, would you allow your engineer mailing list to be public? They're like, no. I'm like, yeah. Our engineer mailing list isn't public, just like yours is. Your pull request for the AI stuff. It's all in public, which is good. We discuss things in public and this is how we get things done. The world likes writing salacious articles about this stuff, but this is just how engineering works in public. Good things. So yes, there's been some pushback. There's been a lot of pushback from developers because it's going to actually make us do some work on the C side. This is forcing us to re-review our C APIs. Because when you write a Rust binding, you have to just document and figure out how, oh, this pointer is coming from C. What is it? What type is it? What is it? Is it owned? Is it borrowed? Or is it passing off the ownership here or not? Is it reference counted? Is there locks involved? We have to document things. And that forces us as a C developer and maintainer to revisit our stuff. And we're busy. We don't like doing this type of stuff. But in the end, it's made us make our code better. Like I said, if Rust disappears today, we've cleaned up our C APIs a lot already because of Rust. We've had to think about, oh, this stuff really should be const, or this stuff really should be not owned by that, or the lock should be cleaned up. Again, the guards were added, things like that. We've taken these good ideas from Rust and added to the C side. This is a good thing because we need it. We need to evolve. We need to make sure our code works properly. Linux always worked, but now we're having to work under hostile conditions more and more with all the AI reviewing tools, the fuzzing tools, malicious hardware. It looks like there's a ton of bugs. It's not. It's just that we work properly well, but with certain bounds condition, when you're trying to be mean to the hardware or the device, the program, it can do bad things. So making that is hard, but we need to fix this stuff because we can make this maintainable easier. If I see this patterns, the compiler works. Because of Rust, I just know the code is correct. Make the compiler do the work. That's what we've learned. We want the compiler to do the real work. We write code for people first and compilers second, but this is better. This is the compiler is doing the work for the people. We're very happy about this type of stuff. And I think, in the end, it's going to be more fun for the maintainers because I see the code, it builds, great, I can focus on the logic. I don't have to worry about the resources. I don't have to worry about where the code is transferred. I can argue about whether, oh, you're copying this from user space to the kernel, and you're validating, well, your validation probably needs to be worked about. I can care about that one function. I don't have to worry about the rest of the stuff because I assume that works properly because it built properly. So this is going to make our users more secure, thanks to this type of stuff. This is a good thing, and we really need this stuff. But we need your help. We have a ton of work to do. The Rust for Linux team has a whole bunch of projects. They have their own, what's it, web word? It's not Zulip. Anyway, there's a good list. They have a mailing list. There's a bunch of beginner stuff to get involved in, a lot of fix-me's, a lot of stuff. They're doing a really, really good job. I need your help. If you want to write some kernel code, please do this stuff. And this is good. We want this stuff. The Linux kernel maintainers, we get together every year and talk about what the processes are doing. Last year, in November or October, we said the Rust experiment is over. It's not an experiment. This is for real. The people behind it are real. We trust them. They know what they're doing. They've shown and put in the work to make Rust a viable language in the kernel. And we're going to make this stick. This is going to happen. So the experiment's over. We're doing this for real. And let's go full speed ahead. And that's what we're going to do. And as always, world domination is proceeding as planned. Thank you very much. So questions? can't see the thing.
Hi, nice talk. The validate type that you were describing, is it also meant to be accessed by the C code, to be used by the C code to do the validation and to mark the interestedness?
I would love the validate model to be used in C. We've talked about doing this in ways like we've done for user, but it requires a bunch of compiler work, and we're not there yet. So let's try do the Rust stuff first. I would love for it to be C. Nobody's done the real work, and it's hard. Benno has done the real work in Rust. Let's stick with that. If anyone wants to send me C patches to do this, great.
Great talk. I was wondering, like, if you could give us an idea of how difficult it is to work in the kernel, because, you know, it would seem kind of daunting, I think, on the surface, to work in that space, and I'm sure we would all like to help. So can you give us a pitch on what that's like working in the kernel?
Working in the kernel is very simple. We are very simple, dumb code. We do not do fancy things. The C code is very easy. It should be written for people first, compiler second. There's some exceptions, like stay away from the scheduler, stay away from a few other things, but the code is simple. We have new people showing up every month. We have 200 to 250 new developers every 3 months, which is insane if you think about it. It is really simple. Kernelnewbies.org has a whole tutorial of how to write your first kernel patch. I've given talks, how to write your first kernel patch. We have a whole section of the kernel just that's there for coding style cleanups. Send us patches for coding style cleanups. It teaches you how to get your email client working. We do work through email. We don't work through GitHub. We don't have a central repository that way. Email is the lowest common denominator in the world. It works really, really well at high volumes. We've never found anything better than this. Set up your email client and away you go. Don't use a web client, email client. There's tons of these out there. It works very well if your English is not your native language, which is a good thing. You can take your time, think about it, post a patch. Email clients work really well. And so kernelnewbies.org, write your first kernel patch, away you go.
So about those panics that can still happen and cause denial of service attacks, do you think there's any juice to be squeezed from trying to catch those at compile time, maybe like adding effects, you know, be able to represent in the type system that this code has all of the potential panics checked?
Sure, I would love that. I don't really know how you do that for some things. Like, how do you do that for this type of vector or this, yeah?
Well, you could always say get and, you know, like match if you get some, that kind of thing.
Sure, yes, I would love that. If you can think of some ways to do that. But rebooting is much less severe as actually scribbling over memory and taking over the system. So I'll live with this. Let's worry about this. If you want to work on this, great. Everybody contributes to Linux in a selfish way. If you want to solve this problem and force us to do things in a way that cannot panic, I'm all for it. So we do have a lot of issues, and we have a lot of work that's done in the C code. We've been adding, we call safety or seatbelts to the kernel for a long time. We have hardening efforts. We have bounds checks on the C code at a lot of spaces. We've had additions to GCC and Clang in order to add special attributes that the kernel now does at runtime, so we can do these bounds, and we can catch these at build time, or we catch them at runtime, things like that. We do have this for C. If you want to give this for Rust, I will not complain.
Hi, I've been looking actually into using Rust on the Linux kernel. Before with C, I had always been a little bit scared on the impact that this could have. You mentioned that you have a lot of stuff that needs further review or rewrite. Do you actually encourage rewriting stuff that's already there in the kernel with Rust?
No, we don't want rewrites. So unless you're the maintainer and owner of that file, just do it for new stuff. Existing C code should just stay alone, and let's evolve forward after that. If you own that file in the kernel, great, worry about it, and then you can switch it out. Like, I've talked to some companies like, oh, you have these drivers, why don't you rewrite them in Rust, delete the C code and add that. Binder right now in the kernel is C and Rust because they're trying to get parity, and then they're going to delete the C code because I trust them, and they are the owner and maintainer of both those. Generally, you don't want to have two drivers that do the same thing. This has prevented some code from going into the kernel that's written in Rust. We had some example drivers that wanted to be rewritten. Like, no, just do it for new stuff. And it's simpler that way.
Greg, thank you for your service. I'm a web developer, so please excuse the simplicity of the question. I've heard of pointers, and I'm excited to learn more about them. The validate method, I'm confused why it is called validate, because it appears to be parsing.
I'm sorry, I don't understand the question.
The validate method that you showed us before on the impl.
Yes.
My understanding is validate typically is a Boolean operation. Is this validated? Whereas we're parsing here into a new type.
Yes.
Why was it called validate, not parse?
Naming is hard.
There's an anti-pattern called parse don't validate.
Parsing, we had to pick a name, right? It isn't even in, we can change it. The good part about the kernel is we have a API that's outside the kernel, from kernel to user space. That is fixed and we can't break. Inside the kernel, we can do whatever we want. We can rename things, we can rewrite them, we can do all sorts of fun stuff. If we get annoyed that this is called validate and we want it called parse, great, we'll do that. But I would argue we're just validating that this memory structure that I have is valid before I now treat it as trusted. I'm not parsing it all the time. It might be just okay, great, like this does, blind pointer cast away, and away we go. I argue that maybe we should actually do some real validation in here of the bounds, but maybe the bounds don't matter. It's fine. We'll come up with a name. Naming's hard.
Hi, thanks for the talk, and thanks a huge lot for the trust that the Linux people put in us on the Rust side for allowing this to happen. It makes me immensely proud to be a Rust developer when I see things like this and talks like this and Rust actually shipping in the kernel. So thanks a lot for that. To the question part of this, if you had one wish for something that could be different in Rust or could be added to Rust, what would that be?
This validate stuff was my wish. Seriously, I'd like to land this stuff, and there's a bunch of work still left to do to land it. We have a bunch of effort. There's going to be some changes to the Rust compiler to get this to work properly. There's a talk later today about that. It's been a multi-year effort, half on, half off. We're kind of working on this. If this happens, my wishes come true, and I'll be happy for now. And then I'll come up with some other wishes. So let's focus on this one.
Good, thanks.
Hi. First of all, sorry for I'm going to mentioning Windows. So as an application developer, I see that the Windows has the official Rust binding for all the Windows APIs. So is Linux going to have something equivalent for Linux kernel API?
So Windows is fine. I love competition. I wish they would give me some real competition. I know those developers. They know they're not competing with us anymore. Microsoft just announced the Linux distro 2 days ago, and they publicly admitted that over 2/3 of their cloud systems are running Linux. That was their public numbers. Anyway, Microsoft makes a lot of money on Linux. My Steam Deck is awesome too. It runs Linux. Rust, for user space bindings, that's what the Rust compiler gives you today, the I/O, the libraries, that's there. There's nothing fancy that needs to be added. That's up to the compiler and the library people. So the kernel to user space, there's no bindings there. It's just there's a C standard syscall API. And that compiler works today. You have your standard library and away you go. So there's nothing needs to be done. We can always work on better ones. We have new APIs. There's a talk about how Alice is adding IOU ring support, which is a new kernel API, to the Rust libraries, things like that. So take advantage of our APIs, they're there. Yeah.
Hi. First of all, thank you very much for the presentation. My question is around something different. Looking back retrospectively, how would you evaluate the cultural friction? And if you could go back, what would you do differently?
The culture of friction of what?
Of getting people to agree to use Rust?
People are hard. These are people issues. These are not technical issues. And that's what engineering is. Engineering is working with technical people, which is another class of people, as we all know, in order to convince them that they should do something. Linux is really unique in that I have 5,000 developers working on this stuff, and nobody can tell anybody else what to do. 5,000 developers, I like saying this, none of us can agree on anything. We can only agree on one thing. And that one thing is that we want to see Linux succeed. That's the only thing we agree on. We argue about everything else. And that's good. And you can convince our minds and change our minds about things. You can convince Linus that, oh, he's wrong with this. You can convince me I'm wrong with this stuff. And this is how Linux succeeds, and we will change and move forward. This is how engineering works. This is normal. We have a huge rate of change, but if you look over time, we're evolving properly with how the world changes over time. We don't change for no reason. We change because we have to change. And so far, we've been doing a good job. We're always willing to reevaluate how we do our stuff. And again, we get together once a year and talk about our process. Do we need to change anything? We looked recently and talked about how we need to handle security bugs that are being reported to us. Linus talked about it this past weekend. We've reevaluated how this process works because we're getting flooded with crap. So how do we deal with this? We're going to start treating anything that's found with a public LLM tool as public because everybody keeps finding the same thing because these tools just feed it back in, and once it pleases you, it's going to find a reported bug that's already been reported. And you have to treat it again? No, do this type of stuff. So we evolve over time, and that's how we work. This is how any human organization of people in a project work. Again, we have one goal. We want to see Linux succeed. How do we get there? We all have different ideas. Let's convince each other of what happens, and we go from there.
Thanks for the talk. My question is, LLVM has a lot less target platforms than GCC has. So what are you going to do in the kernel? Are you going to use the GCC backend or keep using LLVM and try to expand it? Or where is this going to go?
Both. We rely on the platform architecture maintainers to add support. We're seeing patches today for S390 getting added to the kernel for the Rust. PowerPC processors just got posted today. For those architectures that don't have it, the GCC Rust developers are actively working to make it their goal that GCC Rust compiler can build the kernel. That's going to be their minimum viable product. And they're working hard on that. And so that'll catch the long tail of the architectures that don't really have support in the Rust compiler. But if you look, I think the number of those architectures is very, very tiny. And they're like niche architectures that we do have users, we have hobbyists running this kind of stuff, but overall, we're not adding code to the core kernel for this, but drivers coming in new drivers for these graphics cards wouldn't be running on those platforms anyway, so they're not going to be missing anything. But we're leaning and relying on the GCC developers to do this, and we're talking with them and working with them.
Is there like a plan to choose one or the other, or you're going to go with both forever?
Both is good. I mean, competition's good, right? So we'll see. You can pick and choose which one you want to do at build time. If it works for you, I don't think GCC Rust will quite get you there yet, but they're working hard on it. And they had a presentation a couple months ago about what they have left to do, so they have it bounded. Work with those developers. Those compiler people are good.
This is the final question.
It's actually not a question, it's a reply about the Windows thing. What Rust for Linux does is way, way ahead of what is in the public Windows stuff. They have like 5 unsafe blocks in a sample driver that just does println hello world. Like Linux is way, way ahead. You have entire graphics drivers with a dozen of unsafe blocks.
Yeah, there's a demo out there somewhere that's showing it running Rust graphics, which is cool. All right, do you want to do one more question?
Okay, one more, the final one.
There has to be this one question. I was waiting for someone else to put it. But first of all, thank you, Greg, for the great talk. What I would like to know is, does Linux has ever written some line of Rust code?
I don't
Linus
know.
Torvalds?
I don't know.
You don't know?
I'll say what I've read in Rust. So the kernel CVE team, again, our scripts to manage this stuff, it had to be automated. So we wrote it originally in Bash. Horrible. But it enabled us to get it working. And as we scaled and had to deal with more and more and more CVEs, we rewrote all that code in Rust. So all that code, we have a little C program that handles our database of all the CVEs, but all the other wrapping stuff, so if you ever see a CVE published for Linux, that came through a bunch of Rust code. It's public, so that's my Rust code that I've written. I've written very little Rust code in the kernel, but I'll work on it forward. I don't know about Linus, ask him. He's written other stuff, so I don't know.
Okay, thank you. I think that was the last question. Again, another round of applause for Greg for the lovely talk. And we're going to be switching over to the next speaker. So for about 10 minutes, you can walk in and out, quickly go to the toilet maybe, and we're going to be setting up for the next one. Hello, everyone. Welcome back. Please sit down, get into your seats for our next presenter. She's an improvisational sound artist, the processing lead at Processing Foundation, and above all, a person who takes seriously art education and art education through art. Everyone, welcome. It's Moon Dave. My excuses, we've been a bit too quick. Okay, one more warm welcome, please. Let's begin.
Okay. Can you hear me? Okay, wow. I had to pee. Okay, let's go. Hello. Welcome to my presentation. I'm Moon. I use she, her pronouns. I work at the Processing Foundation. I'm the processing project lead. This screen is too big, and it's overwhelming, I have to say. Okay, but what is processing? I'm sure a lot of you don't know. Actually, how many people do know? Wait, really? This is awesome. I wasn't expecting that. Okay, well, this is creative coding. Processing was originally written in Java, and creative coding is a way to like kind of take away the complexity of programming so you can focus on like the art that you're making. And it's also a really great way to kind of, you know, if you're exploring like some like biological phenomena or something like that, you can just focus on that and figure out ways to create artworks with that. And when you're a beginner and like someone who didn't grow up with computers or something like that, this API is a lot simpler to kind of get into when you're learning how to program. And this is really important because I think this is really important because, you know, computational thinking has everything to do with power in our society. And it's, you know, it's a joyful and fun thing, of course, but like, you know, we send code to space, you know, it's like wild. So making sure more people have access to computational thinking is really important to me. Here's some cool stuff that people have made. This was made with a Python version of processing. This is also really cool, and I think this is actually on a pen. This was exported to SVG and then put through a pen plotter. So this is plotter art, really beautiful stuff by Vega. Yeah, and we've been around for a while. We're like a 25-year-old project at this point. This is proof. I thought this was proof at least, but these are just like a bunch of books. Like it's been around for a while. People teach with processing. The APIs are like people have written books around the APIs and to teach with it, which is kind of important. Yeah, and then so I wrote this sketch last night really quick. These sketches can get even simpler than this, but all this is doing is putting a circle where the mouse is. And the reason why it says low floors is there's a concept of low floors and high ceilings. And low floors means it's really easy for a beginner to kind of get started, and they can walk right in, and they can kind of start engaging with whatever, like your tool. And high ceilings have to do with how far you can go with that. This is Times Square in New York City. This is running actually this is a Python-based processing sketch running on all of the screens in Times Square. I never actually saw this until I joined the Processing Foundation. I was like, oh my gosh, this is really wild. We recently had a fellowship, and some of our processing fellows built a tool to do this projection mapping onto those buildings in the back. And it's also a collage tool. So and they co-created it with these high school students who are theater kids, and they were able to collaborate and create this tool that allowed all of them to put material and to put artifacts onto the wall, onto the buildings rather. And I think this is an important thing to me too, because I don't know. I think this really demonstrated something special about changing our relationship to technology, because usually it's something that's imposed upon us, and we just have to kind of go with that change. But I really think that we should be in dialogue when we create our tools, and and so this felt like a kernel of something really special to me. But anyways, if you want to know more, there's a very polished and very good talk at LibreGraphics Meeting 2025. Go check it out. It has really amazing slides. This is a screenshot. That's Raphael, the community lead, with a really cool slide and it's animated. And then this is me referencing it at LGM 2026, and I thought that was very funny. Okay, good, you too. Great. Anywho, I just want to say that what we're going to discuss today is it's all research and development, and that means it can fail. But I'm really excited to talk about what we're talking about, and it's really important to me because to me, I think that this is going to help us kind of get to a place where we're in that world where, like, you're a user, you get to use this tool and dive into it, and then you want to change this tool, you can learn and find a way to contribute to it. And I think, I think it's actually kind of sad that that's not the world we're in now. And I think, so I really want to do whatever work is possible to kind of slowly move us that way. And I actually really do think that Rust can be a part of it, just because of the work that's been done, like in your community. Anywho, we have technical problems in our 25-year-old Java app, and it has to do with our rendering engine. So processing was built 25 years ago in an OpenGL immediate mode world. So I don't know if everyone knows about retain mode APIs or the GPU and like modern rendering hardware, or graphics hardware, which isn't even just used for graphics, it's also used for computing and all of that stuff. And also, the high ceiling it's getting higher, and we want to make sure we have a way for beginners to come in, learn with our API, and then kind of move towards making really serious work. And what is serious work is it's not always possible inside of what our in our existing tools. So so how can we support what already exists, the legacy, while meeting this high ceiling and maybe exceeding it too? I'll just take 1 sec. I'll say this again later, but let me just get to it. We're using Rust and Bevy to improve this like Java code base. The Bevy game engine is a really ambitious and really amazing open source game engine. I actually see it as a toolkit for game engines too, because of its modular design. So you can just take whatever parts of it you need to make the thing that you need. So it doesn't have to be a full-on game engine. You don't need to use Godot, which I'm a fan of Godot, but like just take what you need and like go make the tool and build the world that you want with it. And I think it's really exciting, and everyone's super nice. Here's a diagram. So that top arrow says FFI, foreign function interface. We're using cbindgen, and like we're making a dylib using Rust. This diagram, well, it could be improved. I'm not a good diagram maker, but this experimental library it has to offer these functionalities, like rendering, audio, MIDI, SVG, fonts, input, and that all of that stuff is really, that's the core, you know, and we want to be able to bring that into the JVM over FFI. And we want to provide that functionality using Bevy. And this is also this is a big simplification because we're talking a lot about Bevy, but it's not just Bevy, it's Bevy and like the whole like Rust ecosystem, because things are built, there are a lot of things that are built really well, and you can just kind of find a way to bring it in, you know, use the type system to make like a healthy adapter, and kind of bring that to, we can bring that to our end users in processing. That's kind of the vision. Let me know if I'm wrong, you know, for reals. Anyways, I already mentioned some of this stuff, but yeah, why? Yeah, because it is kind of crazy to do what we're doing. It is a Java project, you know, but, you know, yeah, so yeah, Bevy, modular design. We like the plugin system. We just like use the app module or crate. I don't know what the right word is there. Someone correct me later. But like, but we can just add plugins or make our own plugins and kind of create the thing that we need through that. And it's really nice. Yeah, and also high performance graphics and high performance computing, like that stuff that's like, our beginner community is not like, these are not people who are like, oh, we're going really deep into, like, we're not going to write our own graphics pipeline and kind of really think a lot about kind of like how we're going to do resource management as we pass it into the GPU, as we pass, you know, resources and like code into the GPU. So they can do that, but that's just not where they're at. They're like art students. They have different focuses. They have a different focus. Right, yeah, and I already mentioned this too, but Rust is full of really high quality projects. Also, Charlotte McElwin told me to say hi to everyone. Yeah, wait, round of applause for Charlotte. She's amazing, and I have a engineering crush on her, honestly, because she's so smart. It's like really wild. I can't believe it sometimes. And yeah, she's really fun to work with and smart and talented. And we wouldn't have been able to do this because I'm learning Rust. I've been using it for about a year, but I was reluctant, and I was kind of also like, let's just keep programming in C. C is the language of the people, you know, but I get it now. But like, she's been super helpful, and she's kind of been my like liaison into the Bevy development community, and like Alice is freaking awesome too. Oh my gosh. Also, how does she do all of that like community management and GitHub stuff? Like, I have to get like a workshop from her personally. Okay, we gotta keep going. Anyways, wait, FFI? Yes, FFI. We need to focus so that we're able to make sure these efforts inside of the experimental library benefit the processing Java code base. But FFI to me is really exciting because it also means we can open up doors towards other language ecosystems. 2 days ago, when I got here, I was stressing about this talk, so I was like, I'm gonna start learning Haskell. So I started doing Advent of Code, and I'd finished the day 1, and then I was like, okay, now let's figure out FFI. And so I did use AI, but I used AI to generate the bindings from our like C headers to Haskell, and then I was able to open up a window, and I was like, okay, Haskell, let's just do creative coding in Haskell. Let's put Haskell in the kernel. Anyway, I love this place. I love being around technical people. Okay, so also we did an experiment with PyOxide, Pyo3. It's an amazing project. If you are in here and you're like, I need to get better at Rust, read Pyo3. Also read the Bevy code base. There's a lot of really great ideas in there. But we made a whole like Python library that does processing stuff, and it's really wild. You install the package, and then you run your script, and it literally just like starts up like a really cool game engine like instantly, and that game engine is Bevy. But anywho, these are like the possibilities, right? the research and development. Anyways, we have challenges. I got to keep moving. Well, there is the Rust beginners problem. I think we're all aware of it. If you saw Nico's talk yesterday, he also mentioned it. And as working at the processing foundation, like we're always thinking about that. And, I think sometimes when we think about the beginner too, it's really interesting because, it could be someone who's like me. I've been programming for a really long time and I have a C background and I know systems programming stuff. I could always be better, but still, I'm a beginner to Rust, right? But that's different from a beginner to Rust who's like, I am at NYU and I'm in their ITP like new media program and I'm working with projectors and like hardware and stuff like that. But I'm also really curious. Sometimes some students are really curious and they want to learn about how computers work and they want to go deeper. How do you get them engaged with Rust? Because Rust is not easy to do yet. But I do think there's a way to learn because anyone can learn anything. We just have to create pathways through pedagogy, right? Anywho, also we need a lot more experienced contributors. Charlotte is super helpful. I'm doing the best that I can to like ramp up and like really get more engaged with it. But my job does not, I have a lot of different things to focus on. So I don't get to be like in my room, like really focused on this stuff, which that's hard for me because I really like to focus on things. But if there are people who are really excited about contributing, that would be super helpful, especially if you're a Bevy developer or if you're someone who's interested in learning Bevy, like you can definitely help out. I don't think it's really that hard to learn. Also, we've been in a state of like trying to get a lot of different things happening. Like we explored MIDI, we explored some audio, we've explored compute shaders and everything. We need to scope it down so that the stability we can get to a place of stability for this project. And that's like one of the challenges we had. How do we make like a proper like CI? We need to set up like a CI and stuff like that, which that I can do, but. Anyways, also the FFI boundary grows. So every time we want to add something new, now we have all these like, it's not like a simple layer. And like, I have this vision for people using this like library to make new tools that have nothing to do with processing if they don't want. And like, how can that be made easier? That's like a big question. I think that's a design question, actually. It's like, how do you teach someone who has never really thought about FFI as a concept, and then I say, hey, use this and we're gonna make bindings for it, and now you can go make like a new tool. Sorry, I just started thinking out loud, but like, I think maybe that's for like the person who's like, oh, I'm in the Haskell ecosystem and I'm gonna make this library for that it's like the Haskell processing library thing. And then people build tools on top of that. So I don't know. Yeah. Sorry. I'm not sorry. Okay, call to action. Yeah. I guess this talk could have been more technical, huh? But I just don't know. I didn't know anyone would actually know about processing. But talk to me if you want to explore the code together, like maybe get a demo, join our Discord, check out the GitHub, go do some creative coding. And also, is that my last slide? Yeah, so let me go back to this fancy slide over here. So like, just think about this. This is our current high ceiling, right? How much further can we go in doing this type of creative artwork when you have like a really ambitious game engine underneath and you have a really ambitious like Rust ecosystem that is doing really high quality work? And how can we offer those really amazing capabilities and potentials to beginners who don't know about the stuff that's happening here? And then, how do we create more legibility? But that's so that they're able to get into this room and kind of start solving these problems with all of us here. That's my big question. Okay, thank you. You can applaud now. I'm done. Yeah, I'm done. Okay.
Thank you for the nice talk. Thanks. Are there any questions? Can I have a raise of hands? Yeah, I see a hand there. I'll walk there.
I was curious what the FFI layers look like from, because if I'm understanding correctly, it's Rust through to Java. So what tooling exists around that FFI?
Great question. Thank you for that amazing question. In the Java ecosystem, there's something called Project Panama. Definitely look that up. That's how you work with those binding. You make the bindings. So that whole project is made to like tap into native code and bring it into the JVM. Since the JVM is an island, they need to import. Anyways, that was my big joke. I'm sorry. It's not that funny. Okay, is that helpful? Great. Thank you. Next question.
Thank you for the nice talk. I was curious because I hadn't heard of this tool before, and you introduced it as this idea of making programming more accessible by having this skill floor, right? But then there's also this idea of using Rust to introduce more concepts of what is a computer, what is going on. I'd like to hear a little bit more about that. Like, have you had experience showing Rust to perhaps some of these students?
Yeah, so no, I have not. So there's been curiosity around Rust because people come and they want to try to contribute. And when I'm telling them about this project, they're like, "Oh, I should learn Rust." I'm like, "Yeah," but I'm not an educator myself, so a lot of the students that I see, they're starting with JavaScript, and they use there's a P5.js, which is the JavaScript version of processing, and they go from there, and then they usually kind of leave and move on to like Touch Designer, and so kind of there needs to be some kind of like mentorship, because I do think that where there is kind of an interface to the development work and like learning Rust, and these students it's the code base. So they come and they try to contribute, and like a lot of it is like, hey, just try to get it to run, and we'll update the README and documentation so it makes more sense. But I haven't had a chance to be like, hey, we're gonna sit down and we're gonna learn how to like compile some Rust code and like understand like the hello world of it. But I do want to say actually, so in the summer we're setting up a grant program with NYU. Well, we're not set. There is a grant that is being paid to students from NYU to work with us, and so the goal that we've set up is that they're going to actually try to learn Rust and try to contribute, and then from that, they are going to be the ones to create the educational tutorial material. So it will be coming from a perspective of artist rather than an engineer, and I think this is I have really high hopes for this, yeah. So I'll definitely talk about it once that's happened after this summer. Is that helpful? Okay, sorry, that was really long. Over here on the left front, middle. Oh, also over there. Sorry, I don't know what's going on. I apologize.
Hi. Have you read Brett's Victor article about learnable programming? And if so, what do you think? What are your thoughts on it?
Wait, what's it called?
Learnable programming.
Learnable? Yeah. Actually, I don't know. Can you tell me what the gist is? Sorry to make you do that.
No, sure. So it's about like this introduction to programming type courses and things where like they give you a PostScript like API and here so you can draw shapes and stuff, and basically it says that the way they traditionally do it is so like we show you this example code. So here's how you can draw a triangle, a square. Now you know how to draw a house. And what he says is like there's a component missing of like interaction with a person who's learning, of visual interaction, and often like these introductions expect the person who's learning to like just learn on their own, basically, to like copy paste some code and like tweak some values and like figure out what happens. And what he calls learnable programming is giving interfaces that are more tangible, that react more visibly to what the user does, to teach them how the API works.
Yeah. So what I'm hearing is just the idea of having some code, you tweak the code, you see the change, and you experience the feedback loop. Or now we're having a dialogue. I love this.
So yeah, so that's the basics of it. But like he says, like you can go much further than that, and it's stuff like having your mouse over like the triangle and seeing which like variables it corresponds to in the code, stuff like that.
Yeah, I think that stuff is cool. It also makes me think of some of the work that Will Crichton is doing with he's doing a lot of Rust research and like finding out what it's like to learn about like the borrow checker and all of that. And when you're using it, it kind of highlights what's happening when it comes to like these objects of data, and you're able to see the relationships there. I think that stuff is really, in general, I think it's always a really good idea because so that in order to develop that kind of like understanding, you have to think through the design, in my opinion, because sometimes it can be really confusing. So, but that's like any product. Sorry.
Hi, thank you for your talk. I was wondering, I don't know processing well, so how large is the top layer what you are building on top of? Because it seems as though you are trying to make something really simple that has all of these details. So at the top layer, you have the simple interactions of posting images and doing your interactions with your graphics. And at the lower end, you have the OpenGL and everything. In that path, where do you see that? How do you see that boundary between the stuff you already have and the Rust code you're bringing in? And how do you see that progressing in the future? Do you see more complexity moving over to the Rust side, or how big is that initial block that you're building the FFIs on top of?
How big is the on top of the Rust part?
Yeah, on top of the
Yeah. So we need to be really pragmatic and we need to be really careful about it. It can be potentially very big, but the purpose is to serve processing. So if the Java code base, like, say it doesn't need some like new, like a new SVG renderer, for example, say it doesn't need that, then it doesn't have to opt in to like whatever the shared library has. And so, but ideally, this shared library, we should be able to move towards putting it into Rust. So one other thing about this is, so the code base is really old. Definitely check out the LGM 2025 talk, but we don't have a lot of contributors right now. And we don't have a lot of maintainers right now. And there isn't a lot of interest in Java right now. And so what I'm trying to do is I want to support this project. I don't want to take away like the JVM because people really love it. It's just that we do need a new generation of people to be able to support it. And to me, that answer is through Rust. Does that help answer your question? I can share more details.
Definitely answers.
Okay.
Thank you very much.
Yes.
Hi. Thanks for your great talk. I have a more technical architectural question. So as far as I understand processing, it's more a world model. So you have a world object and you interact with that. And as far as I know Bevy, it's more a query-based approach. So how do you merge both? Do you build a world object into Bevy to interface that, or how do you do that? Thanks.
That's a really great question. Thank you. Yeah, so processing the experience is immediate mode, right? And Bevy does have, has like the ECS engine. And so what we've done is we've artificially created an immediate mode experience. So the way that we render now is that at the end of a draw call, we take all of the buffered commands and we flush them so that we kind of create this like lockstep kind of experience with the frames. Did that answer your question, or did I answer adjacently?
Yeah, it helps. I think I get a picture in mind. So thanks, that helps.
Okay, we can talk more after.
I want to ask a little bit more of a question related to processing in general, sort of. So I know Arduino IDE uses kind of processing-like application for that, but they kind of build it on top of like C++ language. Do you think there is a potential to like try to replace that using Rust? Do you think that would help beginners or not?
Okay, I'm so glad you asked that question because there's a diagram that I didn't put into my presentation. Okay, listen. So the Arduino thing is built on top of the PDE, and yes, like there's like the whole C++ thing. But Rust embedded is a really, really cool thing because it's not just for like Arduino. You can do ESP32 and like there are all these dev boards, like also the Raspberry Pi Pico boards are really cool too. I would really like to see, I don't have the competence to show you this diagram right now, but what I would like to see is we had Bevy on the bottom right of that diagram, Rust embedded. And then imagine if we were able to create like another pathway out where it's like, okay, now you can do embedded development and physical computing is what they call it in the academic space for new media art. But like we can do physical computing in the way that is beginner friendly and that the way it feels familiar at like with Circuit Python and Arduino. But then it's built on top of the Rust embedded ecosystem. So I wish I put that in because I really want to talk to somebody here about that because, that would be an amazing story and it'll be really good for the students. So I really do. I might be like overly optimistic, but I really don't think I'm wrong. Like, I think this is possible if people help because I'm not that smart.
Okay, final question.
Yes.
Not really a question, just something to point out. Have you ever looked into Electrosmith's Daisy Seed and their audio processing library and stuff they do in integrating their stuff into processing and into the Arduino IDE? And they also have some, not so great, but okay-ish Rust libraries, especially for audio processing. Have you ever looked into that?
I've been wanting to check out that platform for my personal practice with sound, but I have not. Thank you for bringing that up. I have not considered that for this particular project, but I will definitely check it out because it's a really great platform. I want processing to land in this place where it's like, I'm able to use like a modular synthesizer and then bring it into Linux and not Mac OS and then do like really cool visual stuff and create like an audio visual kind of thing. But anyways, I just thought I'd drop that in there right now. Sorry.
Okay, thank you. That was the last question.
Okay.
With a big hand to Moon. So we're now heading into the break. all catering is downstairs, so there will be some small snacks and drinks, of course, again. And we will continue again at 11:40. coffee, tea, other drinks. First, before we start with the actual talk, I would like to thank a few sponsors. So we have 2 bronze sponsors. Thank you to Tandem Drive. Thank you. And another bronze sponsor is Polars. So we're going to have a crazy demo presentation now by Yara. Yara has degrees in astronomy, physics, and computing science, if I'm correct. Is an engineer at Z. Maintains the Rodeo crate, which we'll hear about in the next talk, and has a love-hate relationship with her plants, as most of us probably do. Give a big hand to Yara.
Hi, everyone. I'll be talking to you about Rodeo, the oldest and biggest audio crate in the Rust ecosystem. I've been maintaining Rodeo for the last 3 years. And during that time, we've had to make some major changes and take it through some rough spots. Rodeo is a crate for audio playback originally, which means you give it a MP3 file or something, and it will take care of playing that for you on your speakers. But these days, we can also do recording, audio synthesis, almost everything. I'll be talking to you about why we had to modernize Rodeo, how we went about doing that, and then I will be taunting the demo gods, especially since we had some technical problems, with not 1 but 2 demos. Before that, we need to answer one question: how do we make a sound? How do we make our Rust code make us hear something? For that matter, what is hearing? In your ear, there is a little membrane called the eardrum, and when it moves backwards and forwards, your brain interprets it as sound. That means whether it's me speaking to you right now or a full symphony orchestra, that is a specific movement of that membrane. That means if we can control that membrane, we can control what you hear. So how do we go about doing that? We'll need 2 dependencies. We need a speaker and we need air. Any version of these will work fine. As the air hits the eardrum, it will start vibrating. How do we get to do that? Well, a speaker is also a membrane, but one that we can force to move. As it does that, it drags the air with it backwards and forwards, starting to jiggle the air outwards until it hits your eardrum slightly later, causing that to move in the same way. Now, how do we control that speaker? Since we've reduced hearing a thing to exactly controlling a speaker membrane, we give it a list of audio samples, which are positions we would like the membrane to be in. These are just numbers. They're just floating point numbers, and that's something our code can do wonderfully well. The question is, small mistake there. But how fast should we send these numbers? Like, if we send only a few a second, you're talking about really, you can only describe like slow vibrations, slow sounds. And a human ear can hear up to 20,000 hertz. So how many of these should we send to perfectly represent that sound? Well, the internet is widely divided on this, but there is actually just a single correct answer, thanks to the Nyquist-Shannon sampling theorem. I'm going to take you through it real quick. It says if a function x of t contains no frequencies higher than b hertz, let's say 20,000 for us, then it can be perfectly described from its sampled values. Let's fill that in for our situation. We don't care about a function, we want to create sound, and we have 20,000 hertz. And then we get this. With a sample rate of 40,000 hertz, we can completely reproduce any sound we humans can hear. Okay, great. Now we know everything we need to make a sound. So how do we represent this stream of samples, this list of floating point numbers? Well, iterators, of course. We all love iterators. And that is what Rodeo is really about. It is a crate extending the standard library iterator trait to represent sound and to give you ways of getting that sound from the OS, as in recording, pushing iterators into the OS, playback, etc. The core of Rodeo is really this source trait, which is just an extension of iterators over floating points, with one extra method required, and that is that sample rate. Ignore the blue asterisks. Rodeo is simple. We offer you a bunch of nice things, just like iterators do. For example, the simplest effect would be amplify, and you can just call that on anything that implements source. It will take ownership of it, it will wrap it and make it a nice amplify source. You also give it some factor about how much you want to amplify the sound. The actual work all happens in the iterate implementation. Here you can see amplify just gets the next sample from the underlying source, multiplies that by some factor, and returns that. We can make this more interesting if we start changing the factor while iterating, and now we have a fade in. And if we subtract, we have a fade out. And as a user, this gets super easy to use. You have the familiar little iterator chain, and you can pass that out to your speakers, at which point Rodeo will take this iterator chain, move it to a dedicated high-priority audio thread, and start playing it back, interfacing with your web browser, Linux, Mac, Windows, Android, iOS, whatever you need. You can also still control it at this point. We give you the option to pass a callback to the audio thread to put that in there. And in this case, we are modifying the amount of amplification. And every 10 milliseconds it will run, get in some atomic, and we walk back up that iterator chain, calling for initially we get fade in, we call intermute, we get amplify, and we set the factor directly on that. This is really powerful because it means you don't have to use an atomic, you can use whatever works for your application. We also provide simpler abstractions around this if you don't want to mess with this. So, let's talk about game audio. Game audio is really hard. It requires you to manage a ton of sounds and effects from systems all throughout your code base. This architecture that Rodeo uses is not set up for that. So over the years, there have been multiple crates experimenting with alternative approaches. It led us to the idea like, should we not, also Rodeo has two big problems. We'll get to that in a second. Should we not rebuild Rodeo's API, maybe one of those crates that can support game audio? There aren't that many people working on audio, and everybody is short on maintainers and contributors. So it doesn't make sense to split up. So we really wanted to see if we could do this. Turns out that Rodeo's API and all the newer crates didn't really mesh together. Well, but we really wanted this, so we looked into maybe we should just build a Rodeo similar-ish API. These new crates were rather low level, and Rodeo was so easy to use. Could we not still get the best of both worlds? Just build a new API. But then we realized at that point Rodeo would still exist because it's so easy, and this would not be Rodeo. And now we get this. And we don't want this. So one of the things that's important to mention here is, why is Rodeo so successful? It's so successful because it is so simple. It's just iterators with extra data around them. And that's really nice because audio is quite complex, and the field of audio engineering doesn't completely overlap with the field of software engineering. And that means that a lot of contributors to Rodeo aren't actually software engineers by profession, but have knowledge that we really need. So they're important to us. So having a simple audio engine is a big advantage because that enables them to contribute. So we're keeping the crate, but what should it be for in 2026? What's this crate from 2016 for? Well, we want it to be trivial to use without requiring you to know anything about audio. We want it to be fast and offer choices where they are between quality and speed. And it should be easy to contribute to and to extend. So how do we go about making a crate that's trivial to use without any knowledge? Well, we don't do it by making APIs like this. Limiting is an effect in audio that kind of protects you from amplifying too much. And it takes 4 arguments, the most limiting algorithms, which is knee width, threshold, attack, and release. While these are household names to audio engineers, they say nothing to most people, and we cater to everyone. So instead of asking you to pass this along, we ask you to give us a setting struct. All our more complex effects take these setting structs, and we give you constructors for sensible defaults for every situation we can think of. If you are an audio engineer and you want to specify everything, that's fine. Fields are public. You can write this. Okay, so Rodeo is simple. Mission completed, right? No, that's those 2 big problems. They cause us to seriously consider forcing Rodeo on top of some other crate. What are they? Well, the first one has to do with real-time programming. As I told you before, we need to send about 40,000 samples per second to the DAC, to the speaker. You might be wondering, how can this be a problem? We could play back audio fine decades ago. How in 2026 is this still hard? The problem is sharing resources. You have to guarantee that you can send a sample every 25 microseconds. That means if the allocator is held by something, that's a problem. You can't use a mutex, you can't use a file system, you'd think. Most people solve this by having a bunch of string rules. By the way, what happens if we do miss that deadline? Well, that speaker position I spoke about in the introduction, That's now undefined. And undefined things, as we all know, are very bad. And we try to avoid them. Because this will also be undefined sound. And undefined sound sounds really bad, and it's usually quite loud. So the classical way to solve this is to have a list of things you are forbidden from doing, system calls you're not allowed to make because they're slow. This list gets bigger in complexity and nuance over time, and it's really hard to manually check code against that. And it kind of limits, again, contributions to only people who are performance experts. We don't want to do that. So we're experimenting with something crazy. We are going to check for real-time safety in our test suite. Oh my God, this is a horrible thing. Some people who know me know exactly what's going on and the amount of panic I'm currently in. If you want to know, ask me after the break. Getting back to this. So we're going to try to check real-time safety. And this is a simplified example, but it comes down to just, for about 1 million times, try to get an example from the audio pipeline and check how long that took. And if it's longer than 25 microseconds, sound an alarm. In reality, it's a little bit more complex, and we do some statistics and complicated stuff, but still, it's quite easy to do. The problem with any kind of tool like benchmarking and testing is you need a good representative test suite, in our case, a bunch of audio pipelines, and that's a lot of work to build up. So we're going to cheat a little and make this a feature of the crate, which means all our users who are also extending it, because it's a trait, you can just implement it for whatever you make yourself, can also use this and just call report real-time safety and complain to us, hopefully with a wonderful pipeline they made themselves, and we can add it to the test suite and fix their problems. Okay. That brings me to our worst enemy, spans. This is the other problem with Rodeo. So the real-time safety part, we got that solved now. Spans and how they broke us as a team. Resampling is very expensive. That is taking an audio from one sample rate to another. So you kind of want to try not to do that. For that, Rodeo has invented spans, which is a promise not to change sample rate for a given amount of time. The problem with this promise is really hard to uphold. Let's say you have a bunch of songs. You're playing song 3 right now, and it has just promised a span of 2,000 samples. Now, if you click next, maybe only 500 of those samples have actually passed. And song 4 might have a wildly different sample rate. How do you solve this? This span thing doesn't work. 2 things you can do. You can check for it, really computational intensive, or you can introduce random pauses for filling that span. Both are unacceptable. So what we did instead, if we just introduced a new trait. It's compatible with the old one. You can still use the old one. We're keeping that for a while. This one has no spans. The resample rate is always constant. You get to return this once, and then you have to return the same thing. That makes things way simpler. Now it's time for the scary bit. We're going for demos. OK, the first demo I want to show you is world's worst piano. For those who know music, this is what we're going to play. We are just adding some notes to a mixer, but it's a little interesting to see how those notes are being made. So here we're simulating a piano string, and we're doing that by combining a bunch of sine waves. You can see we have about an array of 12 different items there, 12 different sine waves with frequencies that double every time. Those are the overtones of the piano. And if we run this, and we do some fades at the end to make it sound nice, that sounds like this, if it works. I didn't dare play that live for you all. I'm not that good. Let's get to the next example. I really like this. This is voice over IP in under 140 lines. We start with just the usual clap setup to get a nice command line interface, and then there are 2 interesting methods. There is the stream method, which is running not here, but hopefully in the other room, which opens the UDP socket for listening, and then opens the microphone. And it does a whole bunch of things of setup to tell the user, please give us this sample rate, please give us this channel count. If the OS doesn't give us, then we're just going to force it by resampling. And then eventually it takes the data from that in this for loop over here, and it dumps that into packets which it sends over UDP. That's happening down there. Now if we go all the way back up, and we have a quick look at what the other option is, which we are going to run. Go to definition. This connects to that socket. It sets up the speaker. Then it figures out how the speaker is configured. And here we extend Rodeo with our custom socket source that I'll show you in a second. And we then wrap that source by saying, hey, we need to match the config of the speaker. It will sound funny. So resample, rechange the channel, whatever. And finally, we tell this Rodeo to please play this. Please run it on the audio thread. That socket source, again, is super simple. And it's, if you look at its iterated implementation, because that's where all the magic happens, you see it just receives a packet on UDP, and then it converts that nicely back into Rodeo samples and returns the next sample. OK, let's see if this actually works. And I hope, oh no, my mouse went to the other screen. There it is.
Because it could be someone who's like me. I've been programming for.
That's voice over IP. Thank God that's worked. As we're wrapping up, I would like to talk about where we are as a community. The crate ecosystem has gotten huge. There are over 262,000 crates out there right now. At the same time, essential projects keep going unmaintained. I get the itch to build everything from scratch. I have it myself. I have too many side projects. I picked up Rodeo working on exactly one of those. At the time, I didn't know that much about audio engineering. But there were always people around who were willing to help me out. If you build something together, you get to both learn and teach. Furthermore, it's immensely gratifying to know that your work is useful for other people. If you're looking to build experience, I can heartily recommend go maintain a crate. So next time you see a project struggling, ask yourself, is this still being used? And should it still be used? Maybe there's a newer crate in the ecosystem and it is better, and we should just all move to it. It's OK to let something go. And finally, should it be used for the same thing? Rodeo used to be the answer for game audio. Now there are dedicated solutions. If you'd like the answers to these questions, go drag that crate into the future. Make it fun for yourself. Pick a direction. Reach out to your users. Figure out what they need, if they like what they like. They're really knowledgeable and really enthusiastic often. And feel free to make breaking changes, especially on older crate. But please, please provide us an upgrade guide. And finally, it's OK to overhaul things, but prototype it in private. Move fast and break things over there. Then introduce the changes in small, reviewable amounts. I'm sure you'll find the same joy and gratitude in rescuing a Heritage Trust project. As we're ending, I would like to thank the many maintainers before me, those standing by me today, and the many contributors along the way. You have changed my life. Thank you.
We'll be opening it up to questions right now. So if you have a question, raise your hand, and we will get right to you.
Hi.
Thanks for your presentation and your work. I was wondering, are you guys planning to maybe incorporate some feedback into Rodeo? So put a microphone where the user is supposed to be, measure what actually propagates via membrane, air, electricity, everything, and maybe compensate by changing the iterator through the sample you're sending to get the sound you want at the destination, not just at the beginning of the audio circuit.
Okay. So if I understand correctly, you're asking if we're looking into modifying the outgoing sound to compensate for any acoustics problems and echoes. That is really, really complex. Super cool if somebody's looking into that, but it's not something we are doing at the moment. Thank you.
Hi. Have you looked into the LLVM and now RSC real-time sanitizer for your real-time checking you mentioned?
Not yet. The main goal with that project is to keep it as simple as possible and provide something that the contributor can use. But it's a really good idea, and I'd like to talk to you about that later.
Sorry. Also, I am also working on an audio project, and I also currently use iterators. but in C, it's mostly buffer-based, right? And I was worried a bit about performance problems. Do you know anything about that, or is it just no problem?
I'll be honest with you there. One of the things Rodeo struggles with is performance under debug builds. The iterator style API really requires you to build in release mode to get the best performance. Generally, on the systems I work with, you will get fine output with a debug build. It won't stutter too much. But if the audio chain gets really complex, you can run into issues there. So.
You had examples where it was playing a piano. It had like notes. And you were hard coding the frequencies of those notes. Are you interested in adding those to the Rodeo APIs so it's easier for other people? Or maybe even going as far as playing MIDI files?
Those are both really cool things, and I would absolutely welcome contributions. But our core focus right now is to, well, the next thing we want to do with Rodeo is really work on latency and see if we can drop that down. But it would be super cool.
Thank you.
So in your example, you were setting self.next to 1 as a construct. Could you explain what that is?
Is it the piano example or the...
in line 3.
All the way up? No, oh, sorry, these are relative line numbers. I am so sorry. I think you are, yeah. Oh yeah, this is just a simple thing. So to make this performant enough, we're not sending every sample to UDP. We're collecting them in a buffer first. So what this Rodeo source does normally is it returns, if you look at the top of the function, it returns a buffered item. And once we are out of buffered items, then we go read from UDP to get another 4,000. So the reason we set self.next to 1 is because at the end of this next call, we need to return something. So we're returning the first of the samples we just received over UDP, and then setting next to 1. So the next iteration is going to take the second sample.
Okay, thank you.
Any other questions? From the left? Your right, my left.
What cool projects use Rodeo?
Well, one of them right now still is Bevy, which I think is really cool. Rodeo has been the default game engine for Bevy for a long time, and it's been working recently for them. For really large games, it gets problematic, which is why there are newer solutions being developed, and it will soon be introduced. Other cool projects, I have seen people build synthesizers, which I think is pretty creative, because the grade wasn't made for that. There are also a bunch of audio players, and we also use Rodeo at Z for notification sounds and stuff in the editor.
Thank you.
Over there.
Hi, great talk. So you mentioned latency as one area that you guys are hoping to get improvements in. For newer contributors, is there any other areas that people will be able to look into to help out with the project?
Okay, so what will be good areas for contributors to help out? Well, we have a simpler API than setting up that callback closure for people who just want to play something. That's pretty old, and it kind of needs an overhaul to be nicer. So if you want to make a single struct that you can just call a method and give it a path, and it plays the song and give you controls like pause, stopping, amplification, all that kind of good stuff, that would be really nice.
Cool, thanks.
Any other questions? I don't think there are. So I think we'll be closing this talk a little bit early. That's completely fine. Meet us again in, I think, 15 minutes for the talk by Karen Lars. Another round of applause, please. Yeah. Hello, welcome back at RustConf. Take a seat, and we're gonna get going right away. So next up, a woman deeply involved in the goings-on in FOSS projects, a maintainer of both Ariel and Riot OS, and very passionate about learning. Here is Karen Lammers.
Good afternoon. I'm Karin, and I am learning Rust as my first language. Thanks. 1.5 years ago, I wanted to start learning Rust, and I was wondering, how can you learn Rust as someone without any programming experience? So that's the question I'm going to answer today in this talk. About me, I'm Karin Lammers. I'm an independent consultant, and I help free and open source software projects with their non-coding processes, such as governance, strategy, documentation, and community building. I have a background in governance and education, both in study and worked in education for years, so no computer science background. I'm active in AreaOS and RiotOS. AreaOS you might know. It's a library operating system for microcontrollers written in Rust, and we have a booth directly outside this room. I'm a non-code maintainer at both projects, and I'm a member of the Women in Rust community and a member of the Digital Commons Task Force, which is a policy advisory board for the Next Generation Internet Commons program, advising European Commission about the future of digital commons. That's me professionally, but I also really like learning things and building things. I'm always having some project going on. This is just an overview of some projects I did in the last years. I have built my own split keyboard. I have learned knitting, knitted several socks. I'm going to take this one out because I think it's sticking the microphone. And I've also learned German. This is my German Harry Potter collection. When I started reading the first book, it was very hard. When I was at the last book, I barely noticed I was reading German. So I really like learning new things. And after I had knitted some socks, I was thinking, okay, what will be my next project? And by then I was working for several Rust-based projects, and I thought, okay, I'm doing non-coding side. It's super interesting, super cool to do. I would like to know more about what they're doing, about how it works, what they run into. I want to become a better conversation partner for my projects. And I also wanted to learn programming already for years, and I thought, let's start with this. And since I have an educational background, I have expertise about learning and know how to set up a learning process. So I applied that to learning Rust. So what we're going to do next, I'm first going to explain what do you need to learn a new skill, what are the pillars of learning, then how I applied them in learning Rust and my expertise of my experience in it, what were the difficulties I ran into, then some recommendations on how that can be improved, and how you maybe also can start learning Rust as your first programming language. So if you want to learn something new, there are 5 things you need, 5 pillars of learning, I call them. You need a motivation, because otherwise, well, there's no use in starting. You need a growth mindset, a habit of learning, a network of supportive people, and learning resources, of course. Let's go through them. Okay, this is the plan. I'm going to check how am I going to do this for learning Rust. What is my motivation for learning Rust? Well, as I already said, I like puzzles. I like creativity, building things. Programming is perfect for that. And I want to have better understanding of the Rust projects I'm working with and the engineers I'm working with. So motivation, check. Second, growth mindset. This is really, really important. If you want to learn a new skill, it's really nice to know about the growth mindset, because there are 2 ways to look at learning new skills, a fixed mindset or a growth mindset. Fixed mindset is the idea that intelligence is static and this is something you can do, but that is something you cannot do, and that's it. There's no use in trying. While a growth mindset is, I cannot do this yet, but I can put effort into it. I can learn. I can If I work hard, it pays off. And challenges can be seen as learning opportunities. Reward effort and progress instead of concrete results only. And the cool thing is, you can learn this mindset. Because everyone has both fixed and growth mindset in them. It depends per area if you're more towards a fixed mindset or a growth mindset. But you can train yourself to become in an area of growth mindset on a certain topic, such as learning Rust. And you can use previous experiences to set that growth mindset. That's also why I showed the pictures of the projects I did before. I know there were things I was not able to do. I wasn't able to build a keyboard, but I learned, I tried, and then I did it. I wasn't able to speak German, but then I did. So I know I can learn things. And that's really crucial for learning. So I was aware of that. I could say, yeah, okay, that part of the 5 pillars of learning, check, 2. Third thing is a habit of learning. Because if something takes more time than like half a day or a day, you need to build a habit to keep on going. And building a habit takes about 6 weeks in general. To overcome that beginning, I bought myself an advent calendar of Tony Chocolonely with 24 bits of chocolate for every day I was learning. Every day I did a learning block, I call that. It's like 2 or 2.5 hours that I put into learning. Afterwards, I rewarded myself with such a piece of chocolate. I also kept a journal. From the beginning, I wrote down what did I do, how did it go, what was difficult, what did I learn, how did I feel about it. And over time, that really helped me to look back. In the beginning, that was really hard and I had no idea what I was doing. And at a certain moment, I was like, hey, I now understand this, I apply this, so I could see what I had learned. Also, I had a weekly time slot for learning. Fourth pillar, a network of supportive people. Learning alone is hard. And if you can gather a network of supportive people around you, you can ask for advice. In this case, I had my colleagues, I have many friends learning Rust, my partner is a Rust engineer. I could ask them questions about Rust, and they also supported me in the general learning process. And then, fifth, learning resources. I started with the Rust book, the experimental version. There are like 2 versions, the original one and one with added quizzes, really nice. I used that one. I also watched some videos and I used Rustlings on the side. Rustlings is a series of exercises where there is a little program written and one part is missing and you have to fill that up so that the compiler says, yeah, sure, I'll run this for you. The idea is that you learn to read code and to write code and get comfortable with how Rust syntax is written. This is an example of one of the beginning exercises. It works really well. So that was the plan. How was the experience? I started small and realistic because in the beginning I was not sure if it was going to last. I said to myself, okay, we're going to do those 24 learning blocks, the advent calendar, I'm going to eat it, and then I'll check if I continue or not, if my motivation is still there. That went well. In the beginning, I really focused on that growth mindset because I did not study computer science or any technical study, and sometimes I can think like, oh, I don't know if I can do that. So I know that I really need to focus on that growth mindset when it comes to more technical areas, because I am a technical person, I just didn't study computer science. So that focus on growth mindset helped me, the habit was built. I was really happy with the network of people around me. I really had a lot of discussions and extra explanation that really helped. The learning tools, the first chapters of the book were also nice. Combined with Rustlings was a really good combination. There were several things in there that I didn't understand yet because I hadn't programmed before, but was fine. I built 2 programs, a temperature converter and a Fibonacci number generator. That was challenging. The temperature converter, I think I did that in a few hours, but the Fibonacci number generator really took me like 3 or 4 learning blocks, so more than a day, because I got stuck. I didn't know how to do it. I looked something up. I continued, and that was a really, good experience in training my growth mindset. And it was really cool when I had it running. I was like, oh, I made this. So that was really nice. After those 24 learning blocks, I started sharing with more people and also asking more help. In the beginning, I hadn't shared it with so many people because I wasn't sure if I would continue. And by the time of summer 2025, I'd had 40 learning blocks. So about 80 to 100 hours in learning. Then I took a course in computer architecture and organization at my local university. The course was offered only once per year, so it was at a set moment, and it was not combinable for me to do both that course and learning Rust, so I had a break. And after that course, I had a bit difficulties getting back into learning Rust. So I noticed, okay, I need a new plan. I went back to those 5 pillars of learning and checked, okay, where is the problem for me? What do I need to do to get back into it? Motivation. My motivation was still there, but it needed a bit an extra starter. So I submitted a talk for Rust Week to talk about this. Yeah, thanks. That really helped getting me back to it. With regards to the habit, I really blocked one weekly moment. The Thursday morning is now my moment for learning Rust. With Network of People, I also joined the Women in Rust community. They have meetings every 2 weeks on average, and that may help me meet more people outside my own bubble who are working with Rust, and that also really helped. Next to that, I added an extra book as learning resource, which is called Learning Rust in a Month of Lunches. And that book is written in easy English and makes less assumptions about programming concepts and explains a bit more. And that also was really useful for me to go through that book compared to the Rust book. I used them next to each other. So that's where I'm at now, and that's how I want to continue. Looking back at those 1.5 years, what were the difficulties I ran into? First of all, with regards to habit, I'm running my own business, and it's quite challenging to keep putting the effort and the time into learning. So there were times that I had one learning moment, and the next one was like 3 weeks later, which meant that what I learned in that first learning block, I had forgotten half of it 3 weeks later, and I had to redo it. That was challenging. So I'm looking into how can I improve that. That's why I'm now having this Thursday morning every week. Learning alone is also challenging. I do have this network of people around me, but still I'm sitting in my own room and doing learning there. So that's also why I'm talking to a lot of people here. And there is today a meetup for new Rustations to get to know more people who are also learning Rust. So if you're interested in that, look up the Discord, the social activities under new Rustations, and looking forward to it. What was also really interesting to notice is I was really missing understanding of basic programming concepts. What is the purpose of a function or a method, and how do you use syntax? Also, how to get to writing code, how do you structure that? There was a gap in there because learning general programming concepts and Rust, that's challenging. The Rust learning material really assumes previous programming experiences. So it explains how, for example, a function works and how you write it down, but not what is a function, why does it exist, why do we use it? And that was something, took me a while to find out that I was missing that. And because of all kinds of conversations with people, I found it out and could look it up. But that makes it harder than if you've already learned a different language. So the basic understanding of function, method, control, flow. And I think that might be a reason why people are forced to first learn a different programming language. So I'll get to a recommendation on that in a bit. Also, how to get from theory or practice to really writing code. I've asked a lot of people for advice, and often I heard, pick a project and start working on it. Good idea. How do you do that? So if I would give advice on how we can improve this beginner learning process, I would recommend to also explain basic programming concept with Rust, because now it's assumed someone has learned them with Python, with C, with Java, with whatever language. It would be really great to have step-by-step explanations of both those basic programming concepts and Rust syntax. For example, if there would be some Rust links exercises that have a blog or a post or a video totally explaining into detail, like, here's a function, this is what a function is, this is why it's used, this is how it built up, and like dissecting the answer of the rustling exercise and explaining it step by step, and also how you can find it in documentation. It could be an approach as Haiti. Haiti is a programming language used for secondary high school students, and it is really building up programming concept onto syntax, and it builds up towards Python. It would be really great if we could also have something like that for Rust. And it would be nice to know a bit more like how to write your own first program. If there could be these are the ingredients of it, this is a step-by-step thing to follow, that you know where to find the information, how to set it up. And how to use documentation. Because this is an example of documentation. I can explain this, but it takes me like 10 minutes to dissect every single part of it. And when I ran into this the first time, I was like, yeah, okay, give me an hour. After an hour, I had found it out with help of my partner and of friends, but it would be really nice to have some more explanation, like, how do you read this? What does pop mean? What does fn mean? What does, like, that it's really part by part, because I think experienced Rust programmers, it's so common for you that you don't even see this. Now, well, this one maybe it's more difficult, but the more easier ones you don't see anymore, that it can be so difficult for beginners. So that would be really nice if about these things would be a bit more explanation. So if you are a beginner or you know someone who really wants to start learning Rust as their first programming language, I would recommend to make a plan for yourself with these 5 pillars. Have your motivation for learning Rust clear. Develop a growth mindset. Look up YouTube videos of Carol Dweck. I have in the source list of my presentation a link to it. Build a habit of learning. Find a network of supportive people that can both be online or offline or combined, whatever fits you. And choose fitting learning resources. And what is fitting for you, discuss it with people around you. And I think with that, anyone who is interested in learning Rust and willing to put effort and time into it can learn Rust, I believe. So thank you for your attention, and I'm happy to hear what questions arise.
So, are there any questions in the audience? Raise your hand. On the left.
Oh, sorry. So I went to a talk 2 weeks ago, actually, that was this, but for Clojure, learning Clojure as your first language. And one of the things we brainstormed there is like a concept map showing like what are the things in programming, what are functions, what does it mean to build a program, what does it mean to like get a program onto someone else's computer. Do you think that's something that would be helpful here too?
Yes. Yeah. Yeah. Yes.
Thank you.
Any other questions? Oh, okay. Good catch.
Great talk. I am wondering if there are aspects of Rust that you found particularly difficult or like onery, hard to work with, that you feel like would be worth skipping as an early programmer.
Ooh, good question. Well, I did notice, I always hear everyone say ownership is so hard. I didn't find that so complicated because I don't have anything to unlearn. It's just something like one of the many building blocks I'm learning. I guess really sticking to the basics, like how is a program built up, what is a function, what is a method, how do you build it up, and then find it hard to answer. I think I have to think about it, and so yeah, stick to the basics, I would say, and see what's used often in programs. And so far, I haven't run into something specific that pops up in my mind that I think should be skipped, at least not in the book in the beginning.
Then next is the final questions. If you do still have any questions for Karen, she'll be available after the talk.
And I'll be at the REOS meeting.
Great catch.
In the break there, so come there to meet me.
Hey, thanks for the talk. So you said you were learning Rust because you're already a non-coding contributor to Rust projects, and I'm wondering, has this informed that non-coding work? Now that you are able to, now that you have gone into the technical nitty-gritty.
Sorry, I didn't totally understand the last part of the question.
So now that you're able to code Rust, has that also informed your non-coding activities?
Yeah, it's really more easy to write documentation because I now know what we're doing.
Okay, then I think that will be it for this talk. Thanks again, Karen. Lovely talk. The next hour and let me check my times here. Yes, the next hour and 15 minutes, there'll be lunch downstairs. I see some people rushing for the doors. It's fine. And you're all welcome to grab a bite to eat. Any allergies, go to the middle bar. You can ask any volunteer to guide you there too. And lastly, we do need to be clearing out this whole room so we can close it for a bit. So no rush, but keep that in mind. Welcome back, everyone. Hope you had a wonderful lunch. Before we continue on, we should mention a couple of our bronze tier sponsors, namely ExpressVPN and Oxidas Automotive, because everything is computer, including car. Thank you. Thank you. Thank you. Next up, we have a lovely presenter. She's a software engineer at NLnet Labs, working on open source DNS software, because we can have nice things. Give a warm welcome to Arya Tradisha.
Hi. Hi. So my name is Arya. I would introduce myself, but that's completely unnecessary. All you need to know is that I love optimization. It's my favorite thing in the world. Now, today I'm going to be talking about one friend project that I got nerd sniped into, as you always do, and it is about string interning. So I'll quickly explain how we get into this. I'm writing a bit of a Rust compiler. Don't worry about it. Everything's fine, guys. However, something that you run into when you're writing a compiler is a string interner. A string interner gets used for name resolution stuff, which the context is not super important. But this is basically a hash table. We're going to be doing some fun hash table optimizations today. I'll quickly show you how we use it. So here's a simple function. It's some Rust code. And a string interner lets us turn these individual names into unique numbers. This is really helpful for processing later. We don't want to actually deal with big strings. If you can just give me a U32 for everything, life is great. So I'm going to first intern the keyword here. So fn gets this unique number, 91. Then scan gets a different number, 53. Now, different names will always get different numbers. So I can intern U32, next line, parse. And now the important bit, when I intern this U32, the last identifier here, I will give it exactly the same number as we did before. This basically lets us compare names in terms of those numbers rather than actually moving around, big heap allocated strings or even references to stir. That's all the context you need for compilers. Today's victim for our optimization shenanigans is the string interner crate. Perhaps some of you have seen it before. It is a simple and really quite efficient crate. It's just the simple, obvious answer to if you need a string interner. Internally, it uses hash brown. Can I get a shout if you've used hash brown before? Thank you. Good stuff. However, we can get 40 to 50% faster than this thing, and it runs at about 20 million times a second. The optimizations I'm going to be showing you are not like I'm going to use this evil SIMD instruction and I'm going to optimize for the specific characteristics of my CPU. No, I'm going to be talking about optimizations that apply generally to what modern CPUs look like. CPUs for the last 15 or 20 years have used the same sort of characteristics, and you can optimize for this in normal Rust, and you can get fantastic optimizations. I think that, well, actually, here's the show. Can I get a show of hands? Who here has done algorithmic optimization? That's almost, I see all the hands up. Who here has done optimization where you just deduplicate work or something? Yeah, okay, cool. I got all the optimization folks. But who here knows what I'm talking about when I talk about these modern CPU characteristics? Okay, that's still half the hands. Nice. But for the other half, I really want to introduce you to this. I think it's so cool. And also, I just want to show you, I love optimization. It's the best. So let's get started. Now, if you've never done optimization before, welcome. And I want to introduce you to a sort of scientific method, if I may, for optimizing stuff. Step one, establish a quantitative measure of what you want to optimize. In this case, I wrote a simple program that's just going to read identifiers from a file. line by line and intern them as it goes. I'm just going to check how long it takes, like process runtime. Then I'm going to collect a realistic data set for benchmarking. This comes up all the time. It's not strictly necessary, but you will almost always have this. And it's really important to get a realistic data set for what you're trying to do, because optimization often involves specializing for your real-world data characteristics. Finally, you need a baseline implementation. You need to have something that you can look at and say, I can think of a few ways to do better here. In this case, that's a string interner. So let me quickly explain what the actual string interner code looks like. Here's the overall function. It's fairly simple. It's just an intern. We take an identifier. We return an ID. The first step is to hash this identifier, like you would do if you're using any hash table. Then we will look through candidate identifiers in our hash table. These are things that could match our ident parameter. If we find a successful match, we want to be able to reuse that ID, right? But our hash table returns these identifier IDs, these U32s. We actually need to look them up and find the original string to compare to. Finally, if we don't find any matches, then this identifier has not been seen by the string interner, so we're going to give it a new ID, throw it in, and move on. Here are some statistics. Now, these are a lot of numbers. Just focus on the things I'm highlighting. But the most important one here is that we're running at 20 nanoseconds per iteration, which is already great. We're on the right scale. Nothing like obnoxiously silly is happening here. And like when I hear 20 nanoseconds, I'm like, yeah, that sounds about right. I think that's what I'd expect. Unfortunately, then I looked at the other counters. We're taking 188 instructions on average to intern a string. And when I'm thinking about it, it's like, I don't see where that time is going. I can't imagine, having looked at assembly for this and stuff, like, I'm not sure where that time is going. We're doing 30 branches, which are if-else or like your conditional loop iterations. And again, I don't think we need that many. Something feels a bit off. Finally, I looked at the L1 accesses, and this is, I'm just going to simplify a bit. This is basically how much we're using the stack. And again, we're doing like 65-ish loads, and that just sounds like it sounds like there's stuff that we could really shave off here. Again, I apologize for the amount of information I'm throwing at you. Here is the Firefox Profiler UI. If you've ever done low-level optimizations or even high-level optimizations, you may have seen this. I've generated this with Samply. It's really nice. The only important thing here is the one highlighted bar, which says that we are spending 20% of our runtime in the string interner crate in memcomp, a non-inlined, just sitting there. We're going to call this thing memcomp. And that sounds very silly. Like, why? We're running at 20 nanoseconds per iteration, and we're interning Rust identifiers. Why are we calling memcomp here? It just seems obnoxious. So I looked into this. I looked at the underlying assembly, and I realized, oh, it's actually it's like a really minor thing. Now, in our original code, we just wrote A == B. We just want to compare these two strings. But we never explained to the compiler what the lengths of these strings are going to be. As far as rustc/LLVM knows, we might be working with 20,000 bytes. We might be working with 5 bytes. It has no idea. And so it's just going to do the simple, obvious, efficient thing and generate a call to memcomp. Memcomp is going to be efficient for your system. It's generally really well optimized. You'll be OK. But we can do better in this case. We know that if you think about what a Rust identifier looks like, we're talking about for, iterator, while, scan, I don't know. We shouldn't need to do like an entire function call. Function calls cost nanoseconds here. So how do we help? We need to explain to the compiler that we understand the frequency distribution of our data. So first, let's get a frequency distribution. This is, as I said, having a realistic data set is really helpful. So the line in blue is the probability of a particular length of identifier occurring. So if I took like an identifier like 4, that's 3 bytes. So that shows up as 3 on the scale. And as you can actually see, 3-byte identifiers are the most common. That's the peak of the blue line. Then I graphed this cumulatively, and that's where we actually see the most interesting stuff. About half the identifiers that we're interning in Rust code consist of identifiers that are 4 bytes or less. 3/4 are 8 bytes or less. 95% are 16 bytes or less. How do we explain this to the compiler now that we have these numbers? First, let's factor out just the important stuff. We have gotten a string that we've looked up from inside our interner. We're comparing it to some identifier that we want to intern. Initially, we're just saying A = B, and that we know turns into a memcomp. Now we're going to do this cursed thing. So over here, we're using a compiler hint called unlikely. There's different variations of it. And essentially, this allows us to tell the compiler a certain condition in our if-else case is unlikely. And we can't explain how unlikely, but it doesn't really matter. So the first condition here I have is that length is more than 16. We know that only happens 5% of the time, 6%. And by marking that as unlikely, we can tell the compiler, you don't need to worry about this. Focus on the other stuff. And we can do this repeatedly for different probabilities and try to construct this tree-like structure of if-else cases, explaining to the compiler, these are likely things, these are the unlikely things. Under this case, this is the most likely thing. So what were the results? We save 4 nanoseconds. We save 4 nanoseconds! We are talking about a 20 nanosecond function, and we can still cut down 4 nanoseconds from that. I'm going to go through a few other statistics. First of all, we save 20 L1 accesses. We're not using we're not hitting the stack for a lot of stuff now. We managed to inline that memcomp away. On the other hand, one thing that's a little bit weird is that we didn't really save in the number of branches we executed. We're not doing branches more efficiently, really, than what memcomp was doing. Memcomp is optimized for similar distributions. The only change that happened here is that we explained to the compiler that we know what we're doing, we don't need memcomp. This is a really useful trick. If you have some large application where you're seeing memcomp or memcopy or anything that depends on the length of a string, it's really useful to look at the frequency distribution of those lengths and try to separate out different call sites on that basis. But that's that for one optimization. Let's move on to interfaces. So there's a few hills I would die on. One of them is that APIs are key to optimization. Now, if you think about a big project like the Rust compiler, it consists of many large components, often written and worked on by different people, and where components will often change in their internals, but not across components. The boundaries between these components, the interfaces, your data structures, your high-level function calls, dictate how these components can communicate with each other. And often these boundaries are designed to be simple because it's really hard when you have 2 different components to try to analyze what both of them need. So in our case, we're just talking about this intern function where we just passed in a string. That makes sense. You need to intern a thing, it's a string, we're going to pass in a string. Great. But unfortunately, if you zoom out a bit and think about the components that are using this boundary, we realize that maybe isn't the best way to communicate between them. In this case, because we're talking at such a low level, we're talking about nanoseconds here, the thing that matters is being able to read from memory. Our reader function, the thing that's actually calling the interner, is reading data. It's reading from a file. It's identifying where the identifiers are, and passing them as references onto the intern function. But in order to identify those boundaries, it actually had to load data into registers. That's where we want it to be. But the intern function doesn't get that. The intern function just gets a reference. And so it has to repeat that same loading. What we end up with is a case where the interner has to redo all of this work. And it's actually a lot harder for it because it has less information. So we can do better. We can try to understand, okay, the we know that identifiers 8 bytes or smaller, or between 8 and 16 bytes, are the most common. We can try to design something that's more specialized to these. Here's the API that I came up with. So now I've split that one intern function into 3. We have an intern short, medium, and long. And each one of these will now pass different, much weirder parameters that are specialized to what different components need. In this case, the chunk parameters actually hold the data that we needed. There's also this null mask component parameter that I don't have time to explain, but it's another case where both sides needed to compute the same information, and it's easier to make it a part of the boundary and pass it forward. So what was the results of doing this, frankly, kind of obscene optimization? This thing is hard to maintain, it's much harder to understand, and it's harder to use. But we save another 4 nanoseconds. So looking back, we started with a 20 nanosecond function, and we were like, that was great. And now we're at a 12 nanosecond function, and we're like, huh, maybe 20 nanoseconds wasn't that great. Let's quickly have a look. Again, we've dropped another 20 L1 accesses. We killed more stuff on the stack. We've cut down significantly on the number of branches. It turns out that one of the things that wasn't being communicated across these different components was information about the length. Everybody was trying to figure out, is this length more or less than 8? Is this length more or less than 4? And we've managed to eliminate the vast majority of that. And now when I see 11 branches, I'm like, OK, I worked pretty hard on that. I'm not sure I can get much more out of this. I think I could get it down to 5. We don't have time to get it down to 5. Fine. But there was one weird thing I noticed at this point. We're doing 0.3 last level cache misses every iteration. Now so your CPU has 3 levels of cache. Last level cache is the last level. And if you miss that, if a load could not be found within that, we need to hit RAM, which means that almost a third of the time, our intern function will hit RAM. And as you know, RAM is slow. RAM is also expensive. That's not important. Loading from RAM will take 2,000 to 3,000 cycles, right? That is on the order of microseconds. But our function is taking, 12 nanoseconds per iteration? That doesn't sound right. Even if we're doing this a third of the time, that doesn't sound right. What's going on? And raise your hands if you know what this is about. See, 1, 2. OK, great. This is what we all think our code. This is how we think our code works. We call intern. It'll take 20 nanoseconds. We call intern again. It takes another 20 nanoseconds. Repeat. Great. Unfortunately, that would suck. If a single intern function if a single call to intern is going to take on the order of 3,000 cycles, right? You would just get stuck here. You can only do one thing at a time. That's not how CPUs work. This is a lot closer to what your CPU is actually doing. It is not a call to the intern function does not take 20 nanoseconds. It probably takes on the order of 100 nanoseconds on average. But your CPU is able to execute multiple calls concurrently. In fact, the time that we've been measuring right now, whether it's 20 nanoseconds or 12, is actually the throughput of our function, how often the CPU can begin executing another one. You see this a lot when you have memory-bound applications, if you're working with a lot of big data structures, if you're trying to do especially complex problems where you need to read all over the place from memory, your latency is less important than your throughput. Optimizing for your throughput will let you unlock a lot more performance. And this is the basis for data-oriented design, structured arrays layouts, that sort of field. But those are the main things I wanted to tell you about. Shall we have a quick look at our overall gains? So we've saved 8 nanoseconds per iteration. That's almost a 40% speed up. We've done better. We've more than half the number of instructions we have. We've reduced the branches to almost a third. in a code base, in a function that initially looked like, yeah, that just does what it's supposed to. Everything is fine. It turns out there's a lot we can optimize. Now, you may have some questions about, is this really portable, Arya? Are you stupid? Like, you cannot just tell me that like you just did these things and you can cut all this time and this just applies here. So I asked some friends to run my benchmarks. Here are benchmarks from an AMD Ryzen. There's a person whose laptop that's from. We save 47%. Here's another one from an Intel chip. Sorry for the lack of syntax highlighting. We save another 48%. These optimizations are portable. They apply to sort of any chip that you can show me in the last 15, 20 years, any x86 chip. These are general techniques that you can take away for optimizing any sort of small hot path. Sometimes these will also be applicable to larger programs. But the real question now is, that was an obscene amount of effort. I put a month of my free time into this, at least. Hard to estimate. I am sort of writing a Rust compiler that I wanted to use this in. It would be sort of helpful to, maybe use it over there. I could have spent that time over there. And I don't know, string interning was kind of fun, but I have name resolution, right? And even though we got a 40% speed up, it's inside a function that is faster than my lexer. And the lexer is like 10 times faster than my parser, and then parser is going to be 10 times faster than all the type checking stuff. This optimization doesn't matter. I spent a month on something that was kind of maybe a questionable use of my time. Did I have fun? Yes. Now, I see I have a little bit more time, so just some brief takeaways, things that I am glad I have a stage to tell you about, because optimization's fun, and you should do it too. First of all, just optimize the obvious thing first. You don't need to worry about, oh, I could optimize this, but there's some larger problem at scale. Just optimize the obvious thing. That's a better use of your time. Often, your code will have bottlenecks that you don't understand. In this case, the bottleneck for interning is really, it's not how hard our memory accesses are, it's how much work we're doing. Just doing less work will save us more time. And so getting rid of things like memcomp sort of save time for different reasons than we might have expected. But if you approach the obvious thing first, you'll usually deal with the biggest bottlenecks in your code, and that's perfect. Just go do that. Secondly, build a mental model of what you're really trying to do, which is really important for low-level stuff. The CPU is weird. Like, CPUs, in general, do the weirdest stuff, whether we're talking about out-of-order execution, whether we're talking about branch prediction, speculative execution. If you want to work at this level, it's really important to do some research and build up a mental model of how this stuff works, how your code is going to run through the CPU. And finally, learn how to talk to your optimizer, please. I hear from a lot of people about, I hear a lot of complaints from people about LLVM or the Rust compiler, like not optimizing things in a certain way or missing something obvious. And I think it's really important to understand that there is a way to communicate with the optimizer with things like unlikely hints, with things like hot and cold paths. You can explain to the optimizer what you are actually trying to achieve, and you can really precisely guide what the resulting code is going to look like. Sometimes people think that you need assembly in order to make things faster. That's usually not the case. LLVM is just really good. But yeah, that's most of my stuff. I see I've run really fast, so I'm going to share some more fun details. So if you've used HashBrown, so some people will use HashBrown and think, maybe I could write a better hash table. Spoilers, I'm one of those people. And while running through this, I did some analysis. Specifically, I ran the intern call 50 million times. And what I found is that HashBrown is insanely efficient. Usually you expect that When you're doing hash table traversals, you actually need to check your probe lengths will often be more than 2, in the sense of when you're traversing, when you're looking for candidate identifiers, you'd expect, well, we need to check a few times before we find the right thing. Hash brown is not. Hash brown does not play well with that. It will actually optimize things to the point that 99% of the time we just jump to exactly the identifier we need. Most of our time is really we're not wasting time doing string comparisons. The hardest part is looking up stuff in the hash table. So if you're using hash brown, great, keep using hash brown. Don't try to do better. Trust me. And yeah, I have more time for questions, so please, I would love some questions. Again, optimization rocks. You should do it.
Hi. Okay, so in your initial example, you showed that you map each string into a number. Couldn't you optimize like that initial naive approach by instead of mapping string to number, number to string, and then sorting that as an array?
I'm sorry, I don't understand. So, could you repeat your question?
Okay, so next slide. Next. Okay, these ones.
Okay.
Instead of fn equals 91, could you not do 91 is fn, and then you only have to like calculate what your number? Oh no. Okay, I got it. I'm sorry.
Next question.
Yeah, big fan of the string interner. I've also got obsessed with writing my own for a while. So awesome. I feel the struggle here.
Yes.
Have you also considered like using pre-computed hashes and working from there, so you avoid always having to rehash sort of all these sort of interned strings?
Pre-computing hashes to store within the hash table, so that when you need to do a reallocation, that is more efficient.
You avoid the having to rehash the string or sort of the computation whenever you do the checking.
I'm not sure I understand. Let me push forward to you. You're talking about this function?
So like when you're, for example, if you're having to compare different IDs,
yeah,
you can at least, and looking into the hash table, you have everything pre-computed, so you don't have to sort of constantly rehash it, or at least when you're comparing.
Yeah, well, we don't rehash. We don't rehash while we're doing comparisons. So when the intern function is called and it's given an identifier and it's told, here's scan line, turn that into a number, it'll hash it once, and that's the only time we need to hash that case. I believe there was a question over here.
Yeah, sorry, here. I think you said it on the last slide too, but are you open sourcing this code?
Yes. So I have squatted a name. It's going to be called Phonebook because it maps names to numbers, and I like naming things.
Oh, that's nice.
I will publish this soon, TM. I had initially planned this as part of a bigger project to write a lock-free concurrent hash table for string interning. That did not go so well, but I would still like to add that in that crate. But yes, I am planning to put this up soon.
Okay, thank you.
So is this using the standard hash function or a custom hash function?
So the original code uses hashbound, which by default uses full hash. I believe we have a hashbound person over here. And the full hash crate is really efficient. It's designed primarily for speed while giving good quality hashes. Once I get to this API, I basically inline and mess with the way full hash works to suit this instead. But I fundamentally use the same structure.
So the first.
Sorry, where are you?
Here.
Oh.
In the first step, when you use ECDF, I know it would be less fun, but have you compared that just compiling with PGO?
That's a good question. So in this case, so are you talking about PGO on
profile guided optimization?
Yep. Yeah. On this function, or
so instead of doing this, like using unlikely annotating yourself, just collecting some data on,
So there's two problems here. First of all, you'd still have to write something vaguely like this in order for PGO to have branches to understand. For context, PGO is profile-guided optimization. The basic idea is it will collect statistics about, among other things, how likely your if-else branches are, and basically do the same optimization I'm doing here, but mostly automatically. The problem in this case is that our original code looked like this, no branches. And so PGO would not help us here. You'd have to start with something that looks vaguely like this, and then PGO can help you. The other problem is that, as you'll notice, my conditions here are not all the same. I first have length more than equals 16, length more than equals 8, length strictly greater than 4, and length equal 1. I picked these by spending 2 hours looking at the raw data and figuring out there are certain categories of optimizations, there are certain categories of lengths that I can work on. So for example, if I have a length between 2 and 4 inclusive, I have a particular way of implementing that. But I could not do, for example, 2 up to 5 inclusive. However, there are a bunch of different choices I have. And if I tried to run this under PGO, it would only be able to capture the ones that I actually implemented. There's a question over here. Thank you.
Hi. I am also wondering, like, the statistics you've shown.
Yeah.
What tool are you using to collect them? Those, yeah.
Sorry. Oh, okay. That's a great question. So I have a crap ton of infrastructure for this project. I have 1,500 lines of Python and another 1,000 lines of Rust. I'm collecting these hardware counters using the perf subsystem. You may have heard of the perf command on Linux, which lets you record some of these statistics. Underneath it, it's using the perf subsystem, which actually allows you to access hardware counters. I wrote some Rust code that will extract specifically the counters I need. And get them in a way that I can run multiple iterations, do some linear regressions and stuff. I did not want to write a bunch of statistics, hence the Python code. My apologies. There's also, I believe it's on the slide here, but at the very top it says statistics for YLS. What exactly is YLS? YLS is a jujitsu change ID, because this needed to be more cursed. The essential idea, and I believe I can just show you the slide, the actual code base. Okay, cool. There it is. Sorry. Okay. I apologize. Sway is being Sway. Okay, there it is. Got it. Okay. Let's see if I can zoom in here. Okay, so that might be a bit too zoomed in. Nope. Okay, well, we'll run with it. I'm going to zoom out a little bit. Okay, so here is how I actually implemented all of these optimizations. These are individual Git commits, starting with use string interner, inline some stuff. I tried a bunch of different optimizations along the way, hence there are commits that I didn't end up using. And my infrastructure lets me check out and compare different iterations here on demand. So I can just run SpiceQB. For example, PKY is the using string interner. YLS is the very last optimization I did. Okay, I should disable frequency boost. But it will run it. It will first do a warm-up step. This is primarily inspired by Criterion, which you may have heard of. Criterion only lets you use a single statistic, usually the wall clock time. But I needed 20, and I ended up writing my own tools to do this. But it uses similar statistical methods. But yeah, so this will extract the exact information I needed, show me all the improvements, etc., etc. I'm going to publish this with my slides.
Time for one more question.
Yes. Please let it be from this person.
Thanks for the shout-outs to Hashbound, and I also want to shout-outs to the author of Fault Hash, who I know is at this conference and maybe in this room.
I'd love to meet them. Are they here?
Maybe in another room.
Ghost.
One thing that I noticed is that when you started passing entire strings just in an integer, the first thing that came to mind is how spectacularly does this blow up on big endian?
I'm going to counter that. How spectacularly does fold hash blow up on big endian? Because this will blow up equally spectacularly.
It should just work.
Then it should just work.
It might return a different result, but it should work.
Yeah, so I mean, I have a similar situation here where, well, it's fine for it to return a different result for a hash function. So yes, that is exactly what would happen here. I'd end up with weird results. In terms of the sort of weird overreading I'm doing, probably some CFGs would help. I might need to change a few offsets here and there, but mostly fine.
Great.
Thanks.
Okay, and that's the end of the talk. In 10 or so minutes, we're going to have the next one, so feel free to move between big rooms. And yeah, one final applause, yes.
Is the audio good? Yeah. Okay, we're about to start. Please take a seat. Don't you love it at a conference that you're watching people and you see them learning things? Like their face lights up. Oh, yeah, yeah, yeah. So that's also Hazel's favorite thing, or one of the favorite things. Hazel is our next speaker. She's a fellow at the Niven Lee Foundation and also the infrastructure witch at Hackaderm. And yeah, so give a big hand to Hazel.
My name is Hazel Weekly. I have thoughts, lots of thoughts. They never stop thinking, and they never stop thinking. So when I was thinking about programming languages, I realized that one of the very first things that I wanted to do in university was actually study them. I almost did a PhD in programming language theory because I had these wonderful aspirations of, if only I built the perfect programming language, everything would be fixed. People would be able to communicate better, problems would be solved. I was naive and in my 20s. What can I say? But it turns out that that's not possible. However, it also turns out that I ended up not doing that because making money in industry sounded slightly better, and you can just be a nerd on the internet. No one will stop you. So I decided to do that. But as I progressed throughout my career, I realized that I've had a huge variety of interests, and secretly, they're actually all the same thing. When I was interested in programming languages, when I was interested in communities, in infrastructure, the front end, the back end, up and down, sideways, all the things, it's always been about how do I take people and make them better at being people? How do we embrace the beautiful complexity and messiness of humanity and make it something that's meaningful and help us do what we do better? And I realized that programming languages originally, way back in the day, didn't really used to be like that. They just used to be a tool. But at some point along the way, they stopped being just a tool and started being something a bit more. But before we start talking about that and all the things that we found so interesting and fascinating about that, it's really hard to talk about where we are and where we're going without understanding where we've been first. And so one of the things that I want to talk about is the historical days, the way back days, the early days of what programming kind of used to be like. And so I had the opportunity once to sit down with John Hall, Mad Dog, as you might know him, and he is quite a character in the Linux community, but he's also been quite a character for longer than many of you have been around. And so he told me once about programming and how it used to be. So programming languages weren't really a thing. Instead, you had computers, and by computers I mean mainframes. And these were holed up in a university somewhere, and if you wanted to use the code, well, tough shit, it didn't work on your computer because it was written for someone else's computer, and no two computers were alike. And so you just had to find it somewhere, look it up in a library, dig in, find the person, chase him down in a hallway somewhere and say, when you wrote this function, what were you thinking? Why did you do it like that? And then you had to work together with them. And then if you wanted to submit a patch, you didn't submit a patch, you just had coffee with them. And then you chatted with them, and then you both bitched about how useless the code was and how annoying it was to write this thing and how super, super ridiculous. And basically the experience of mob programming at a conference was the only way programming worked. And that's kind of cool because the concept of community and the concept of programming were one and the same. But at some point, we lost that. When we gained programming languages, when we gained compilers, when we gained computers, when we gained the internet. All these really, really cool things that helped humans build these communities somehow simultaneously meant that the concept of programming kind of stopped being about communities. And so when I came along and I started really thinking about programming languages and researching them and digging into them, the ones that were really fascinating to me were, of course, the cat girl ones. But not just because of the cat girls. It was actually about the types. It was actually about the fun, cool things you could do in language. It was all these intricate things. But at some point, I realized there's these two languages that we talk about a lot, and almost sort of the same terms of they have a lot of the same nice things from a technical standpoint. They all have these same sort of cultural values, but somehow the communities are so utterly different. And as someone who used to be on the board of directors of the Haskell Foundation, I got to see sort of what the community struggled with, what the leaders of the community struggled with, and what we were working on. And then I also got to see sort of in this weird sort of way, this young upstart language come in and out of nowhere steal all the cat girls. Just all at once. 2014, all the cat girls are doing Haskell. It was the cool language. 2024, all the cat girls are doing Rust, but some of them are puppy girls now, and I don't really understand that. But, you know, it's just, what's the difference, right? What was so different about these? And I realized, you know, when I talk about Haskell, I talk about the language, and when I talk about Rust, I talk about the community. And I think that's so fundamental. And I think that in many, many ways, it explains a lot of this. Because both of these languages have a deathly fierce competition to be the worst possible language to teach to a beginner. It's a fierce competition. It's a fierce competition, but between, you know, the higher kind of types, the proc macros, the recursive, you know, Rust underscore bootstrap equal crimes, like there's a lot of weird things happening, and you just dump people into the thick of it. So when you build a community, communities form around this thing that they call common ground. Common ground is really, really important because it's the context that allows us to communicate with each other. Imagine if, you know, I wrote a program, and I gave this program to you, and I just said, look at it. How would you do that? You'd have to open up the code, but that's assuming that you know how to open up the code. That's assuming that you have a text editor. That's assuming that it's written in a file system, and that file system is sort of kind of almost maybe sane, and the text encoding has to be right, and the program structure has to be sensible, and by sensible I mean the same kind of cursed nonsense that you're used to, because the other cursed nonsense that you're not used to might be so different you don't even know where to start. And so if I gave you a program written in Smalltalk, you probably wouldn't even know what to do with it, because it's not a program, it's a virtual machine, it's a binary, but also the text editor and the code and every other thing you've ever heard of or not heard of in your life. And if I gave you, you know, a Rust program, you might go, oh, that's neat. What are all these angle brackets? They scare me. But if you're a C programmer, you know, that's actually fine. And if you're a C++ programmer, you're like, there's not enough angle brackets. And this common ground is so important, because if you don't have that common ground, you can't build this other thing that you need, which is cognitive scaffolding. So cognitive scaffolding is, in many ways, the term that you would use to describe what you do with the education system. Not the part where you burn out a bunch of disillusioned people that later go on the internet and learn how to program on their own, but the building up over and over and over again from simple concepts to complex ones, that cognitive scaffolding is necessary. That's where you build a language, and the language goes, oh, we have figured out how to solve these simple concepts, and now let's build on top of that and make it even worse. And let's build on top of that and make it even more complicated. And let's build on top of that and make it even more complicated. And all of a sudden, you're sitting there and you're talking about like nested array borrowing and non-lexical lifetimes and all this other weird shit that wasn't even conceivable 8 years ago. You've built up so many layers from this shared common ground that you're able to have a deeply sophisticated conversation. And you're able to have a rich and vibrant community, assuming the community can support all of that. And by assuming that the community can support all of that, that's carrying a really, really big assumption. When I talk about that assumption, it's difficult, right? Because a sense of belonging is the thing that psychologically humans require in order to be in a community. If you don't have the sense of belonging, you just have a bunch of people in the same room. And that's not a community. That's a conference hall. And then more specifically than that, why does the marginalized part matter? So the reason the marginalized part matters is common ground can't be built off of the same paths being tread multiple times in a row. You just can't do that. Common ground actually has to be built off of these diversity, off of these shared ideas, off of the combination and a little bit of friction. A little bit of friction, and actually maybe sometimes a lot of friction. Because the strength of building this common ground, the bricks that you use to lay this foundation are actually something that we call social dilemmas. And if I think about Haskell and Rust, and I think about these things, one of the things that comes to mind for me is the Haskell community stayed primarily focused on the tool and on the language because when they encountered the social dilemmas, they schismed and they fractured. And I think that one of the huge reasons why Rust has done such a good job of staying as a community and feeling like a community is because every time you've had these social dilemmas, you've used it as an opportunity to identify how to help the marginalized communities around you and bring them in and make them feel welcomed. You had these social dilemmas of, this is a complicated fucking language. Who's supposed to be able to learn it? And you solved it by building some of the best beginner documentation and books and things out there. And you said, you know what? We have this fearless concurrency. We have all this other cool, great shit, but no one actually knows how to build, atomics and lots and all these other complicated things. And then one nerd in the corner decided, I would write a book on this, and wrote a book that was so good that people that don't even use Rust or care about it read that book to learn the topic. You take social dilemmas and you use them as ways to build community, which is what you're supposed to do, right? And so many times I see these social dilemmas being used to fracture a community. They see the opportunity for growth and they go, I'm comfortable where I'm at. And that builds pathways, it doesn't build common ground. But when you have the social dilemma and you want to solve it, the social dilemma needs to be acknowledged. It needs to be named and it needs to be brought out. It requires people sitting there established in the community, willing to say, I have no idea what's going on. And that is so difficult. It's difficult to be in the community, to be comfortable, to have this knowledge and this establishment and this trust and say, actually, I think I'm the idiot right now. Actually, I don't know. Actually, you know what? I'm going to disclose something. I don't really know. And to their credit, a lot of languages do have these people in them, especially of the academic bent, especially of these types of forever learning. But when the only people that can disclose these vulnerable, I don't really know, and be treated with respect are the pillars of the community, then the community is only as strong as its weakest pillar. But when everyone can say, you know what, I don't really know, let's figure this out together, then the strength of the community becomes the strength of everyone joining together. And that is incredibly powerful. And so as I think about, this story of
back in the day, how people programmed, if I think about, the evolution of the languages that I've loved, the evolution of the communities that I've watched grow and mature and even die, something that comes to mind is people grow, people change, things happen, but what never stops happening is you're never going to stop encountering someone who's brand new to this problem or brand new to this situation or brand new to this environment, and they go, I have no idea. And they ask the same question that's been asked so many times, they're sick of it. Or they come in and they say, I don't really know. How do I start? Or they come in, and this growth of energy, this is like a micro social dilemma. It's like a tiny little thing. It's how do you grow as a community without being able to foster and encourage that growth and that joy in the beginners? Do you take the Stack Overflow approach of saying, close this duplicate? Or do you take the approach that the Rust community has often taken, or that the CNCF community has taken of, okay, we're going to have beginners, we're going to have these introductory things, we're going to have over and over again these same patterns. Let's embrace them. Let's find the joy in people's lived experiences, and let's take that as an opportunity to do something magical. Or you could take the other option, right? You could take, because when you take a community and you say, this community, what if I build it in a way that's really, really comfortable, really, really nice for those who are existing in it, for those who already have all the paperwork done, for those who've been there, read that. You often end up with a combination of benevolent dictators for life. You end up with a combination of, this is for experts, you can fuck off. You end up with a combination of RTFM and something called contest cultures, which is when the progress, when the skill of something, when your success and belonging in the community is predicated on how much better you are than everyone else. It means that it's no longer a community, it's a whole bunch of scared individuals in a room trying to find a legitimacy that they cannot give themselves, and trying to find in others a legitimacy that will never be granted. And that breeds such a toxic environment that the community cannot ever sustain its growth and ends up dying out in some way or another. And this doesn't have to be, I can write memory save code without a borrow checker. It can be something as simple and innocuous as, you're just holding it wrong. People who are experts, they just know how to do this way. Yeah, sure, there's 8 different libraries for this thing, but everyone knows you just use this one library. Or, yeah, there's not really any documentation, but you just have to know, right? And all of that can still be that toxic environment. All of that can still break the community. And so when you think about this belonging in those environments, it's not actually a sense of belonging that you're building. It's a performance. It's a drag. It is this character show of, I'm in this community and I know that because I have all these, signals, these magical indicators of competence. I use the right text editor with the right settings. I write my programs in the right way. I have just the right documentation in the right places. No documentation where it shouldn't be. And you do all these magical little dances of, I belong, right? Please let me belong. But then it doesn't end up petering out. It doesn't end up working in the long term, because you can't build a community on top of scared individuals who have to fight to show that they belong. And so as we think about what's going to happen to communities in the future, one of the things that really, really comes to mind for me is in the very, very early days of computing, the community was the default because of the centralness of it. You couldn't program without severe access to a community because the computers had to be communally shared. But now we have this community, we have a plethora of communities, and we're actually, if anything, in danger of this algorithmic commodification and this death of the community. Stack Overflow is dying, Reddit is kind of toxic and weird. All these things, the user groups, the news boards, the Usenet. Most people here don't even know what Usenet is anymore. Like all these, the IRC, no one can use IRC. Doesn't even really exist. All these places, all these spaces where we built communities have been turned into an algorithmic filter that prevents communities from ever being born in the first place, because you can't build engagement and content and anything around that. And if we think of taking knowledge and locking it up into an artificial creation, then if the community existed to share knowledge, what happens when that knowledge is algorithmically distributed to people and you no longer need or want to share it? How do you build a community in a future where systemically you're not only disincentivized to do it, but the tools that you are surrounded with prevent you from even doing that? And so I'm actually kind of nervous about that, if I'm being honest. I don't really know what the community and what the future is going to hold for programming communities. I don't, even now, I don't know what to do when a beginner says, how do I get started? And I'm like, I don't know, man. Is the world going to be around in 5 years? Like, it's awkward. If someone says, oh, will I get a job with all this knowledge? And I'm like, you could 10 years ago. You probably could today, but I don't know. It's... Well, I want to learn this thing, but also the AI spits something out, and it gets rid of the learning, but also it's wrong half the time. And I'm like, oh, yeah, you just need to... wait a minute. If they just need to know the answer already, but we have no way to give them the answer, we just kind of fucked ourselves, didn't we? Shit. Yeah, so I don't know what's going to happen there. I don't know what the communities of tomorrow are going to be. I don't really know where they're going to live, what they're going to look like. I do know how they're going to work. And the reason I know how they're going to work is because human civilization, human life, human community doesn't look anything like it looked 20 years ago, and it doesn't look like anything it looks like 200 years ago, and it certainly doesn't look like it used to look like 2,000 years ago. But it still works the same way, because we're still humans. We still work together, we still share together, we still operate as a social species of oddly hairless apes that really, really like being nerd-sniped by weird problems. And that's never going to change. And so if I think about the future, and I think about how nervous it can be about all this uncertainty, the thing that I use to center myself is when these communities evolve and change and morph into whatever shape they're going to be in the future, I don't need to worry too much as long as I embrace our humanity and look for the humans and help them feel that belonging no matter where they are, beginner or expert, big or small. In the end, we are all one community, and in the end, no matter where things live, source code or not source code, town hall or library, in the basement, not in the basement, in the forest, in a post-apocalyptic wasteland, who knows? But we will figure it out together, and that gives me all the hope I need. Thank you.
Thank you, Hazel. We'll open the floor to questions. Are there any questions? Yeah, here's one.
So when it comes to a new programming language or a new technical community of any kind, wanting to build the right kind of community, what would you say? How would you say that you know they're on the right track?
I think one of the important indicators for a healthy community is, does the community care for the marginalized community members in it? Because the marginalized community members are the ones that intersectionally both have the most innovation and also have the most challenges. If anything, they're the canary in the coal mine in many ways of, is this community healthy? Is it not healthy? The signals for that are indicated by caring for those marginalized people that fall through the cracks. When a community grows, you basically have three kind of categories of people. You have people that are new, they don't really have another community and they need one. You have people that are passing through, and you have people that can't find another place to belong. And those are the three main categories. And so if I look for the sign of a healthy community, I look for a healthy community that can retain the people that are new, and that can retain the people that don't have a place to belong, that are the good category and not the bad category of that. And so a lot of people that don't belong in another community, it's because they're assholes. But there are also a lot of people that don't belong in another community or that can't find another community because no other community will accept them. If you can retain those and the beginners, that is one of the strongest signals to me of a healthy community. And then further, with the community, if they can solve a social dilemma, that is the strength of a community, and that's the sign of its health. And so, not to talk about the elephant in the room too much, but if you were to, for example, have a community struggling with AI usage in it, and writing a policy somewhere about how to regulate AI usage or think about it, the existence of the policy is not the sign of a healthy community. Coming up with a question or coming up with a problem is not the sign of the healthy community. The sign of the healthy community is recognizing this is a problem, being able to articulate it, and being able to come up with a resolution together that doesn't punish the marginalized community members or exclude them. That resolution process, the feeling of being able to build this together, isn't necessarily going to be pleasant, but it's a healing process, and that healing process brings the strength and the health of the community long term.
So as a follow-up question, sorry, if there's anybody waiting, just let me know. As a follow-up question, so to summarize, I guess, I'll summarize first. You think that including marginalized groups and retaining both them and other members of the community is that biggest sign of health. How does one identify these marginalized communities over time?
How do you identify the marginalized communities?
Mm-hmm.
They're pretty easy to find with the colored hair and the but no, so to answer that seriously, identifying marginalized community members is tricky because marginalization is deeply intersectional. So you need to find the intersections that are supported systemically by the community, and then find the friction points in what is not supported systemically by the community. So for example, in most programming language communities, the marginalized people are not actually necessarily the queer people. You might think, oh, they're definitely marginalized, and they are. But a lot of the queer people that find success in programming circles are also white, they're also affluent, they make a shit ton of money, they work in a job with a lot of free time, and they have a whole lot of affordances that allow them to live a very independent and weird and marginalized life in a relatively safe environment. They can move to an expensive city, and so they're marginalized in some way, but not marginalized in a lot of others. On the other hand, you might actually have marginalized community members that don't receive a lot of support, and that's because they're, quote, normal, but live in an impoverished area. And so the structure of what the community supports, the structure of what the society around you supports, and the affordances that just kind of come by default, that the missing gaps there are really where the truly marginalized community members are. And you can't always find it, but usually you can find them because they've left quietly over time. And if you're finding like the missing voices by listening for what's no longer being said, then you can start to find where some of those marginalized people are.
Hi.
Thank you.
Here. Hi. So what do you think Rust and its community is doing better or worse than Haskell and theirs? What do you think Rust and its community is doing better or worse than Haskell and theirs?
So what do I think Rust does better or worse than Haskell?
Like in terms of the community.
In terms of the community. So that's an interesting one. I think the biggest thing that the Rust community did was they had a very intentional focus on actually building a community. The Haskell community more or less spun up by accident, because the Haskell language was a programming research language that was actually originally built because 5 different universities were building their own programming language to do research in the late 80s, early 90s. And so they all came together and they're like, let's stop duplicating work and start writing better papers. And then accidentally, people started using it for real things. And so there was never a focus really on the community. But from the pretty early days with Rust, they were like, yeah, we're here to solve real problems and also community. That was kind of always explicitly laid out. And so I would say that explicitly laid out and spending real time and energy on it rather than having it be a happy accident or an afterthought is a huge thing that I wish most programming languages did. And certainly I don't think Haskell did that to the extent that it could have.
Thank you.
Not quite sure how to phrase this question, but you talked about and mentioned the trajectory of a community resulting from the behavior of the individuals in it, and that being driven by human needs of belonging. And over the course of a person's life, they might come to know how to have those needs met, but that's something that each person has to figure out. And humans have finite lives. And so I guess my question is, do you think we'll sort of forever be solving the same problem? And not that this is necessarily a bad thing, but solving the same problem over and over for all the new people that are born and live and die. Or do you think we will make long-term progress over the span of several lifetimes, and so that when we look at, say, the history of computing or programming and think about what that might be in the future, will we end up somewhere really different, or will we just sort of continue to get better at solving the same problem over and over again?
So I think we will simultaneously be solving the same problem over and over, but also the way we solve that problem is going to differ over time to the point where in context it looks like a different problem because the environment is completely different. And so, for example, human tolerances come in waves, and human community formations come in waves. And so, in the Renaissance, you had a whole bunch of liberal movement, and then after the Renaissance, you had a period of less liberal movement, and then back and forth, and that keeps happening. But every cycle is a completely new context. And so even though you're solving the same problems in different ways, the context in which you do it is so different that the problem is worth solving in a new way. So a programming language community might, 50 years in the future, go, oh yes, we need to care about marginalized community members, and we need to care about, making inclusive spaces, but the inclusive spaces might be in such a completely different way that it doesn't make sense to think about it that way anymore. A really concrete example would be in the very early days, like the 60s to the 80s, one of the big inclusive things you need to realize was the people punching the cards in order to build and actually slot the machine code into place were often black women. And so you needed to make sure that one of the huge movement things that had to happen was making sure that these marginalized people could safely enter the building and safely leave the building, and they had bathrooms in the building and all these weird things. And so we're still talking about, women in tech and making sure that women in tech are, accepted and welcome, but we're no longer talking about making sure that people punching the cards can safely enter and leave the building. And so same problem, different flavor. But the context is so different that we do make long-term progress over time. For one thing, we don't punch cards anymore, which I think is pretty cool. But yeah.
We have time for one more question.
Yeah, hi. Like for me, one thing I've like heard some people talk about, and it's like a feeling I get from following discussions online. It's like Rust feels to be a bit on the like transition point where like so far it was mostly people coming to it like wanting to use Rust, wanting to get into it, wanting to get into that community. And now there's more and more people who are like using Rust just because it's for their job. The project is already written in Rust. I was sent into the project and I'm going to learn Rust now. But it's like a different kind of mindset. And I guess if Rust is becoming more successful, it's going to happen at some point. Like how you propose, or do you have any ideas how to like the community could deal with that, integrate these people in a like constructive way? They're coming like from a different background with different motivation without losing like that sense that's also making the Rust community special right now.
And so that's a really interesting question, because being the victim of your own success is both great and also not great. So I think Java is a great example of that, where you have a whole lot of people writing Java and they don't care. They just go in, it's their job, and then they go home and they do literally anything but computers. And that's fine. You don't see them at the programming conferences, you don't see them in the hallway track, they don't really go out of the way to learn anything new. And so in many ways, using Java is not part of their identity, and they don't really consider themselves part of the Java community. But they use Java. And so you're probably going to, with Rust, end up with an increasingly large amount of people that using Rust is not their identity, it's not part of their community, it's just part of an intersectional bit of their identity that makes them up in some way. And so you can go too far and try to make the community, inclusive by, just walking up to people and going, you want to join everything. And if they don't care, they don't care. It's fine. But so sometimes the problem doesn't need to be solved. But sometimes when you accommodate things, the reverse can happen. So like with Python, when Python started getting this huge resurgence in data science, all these people that liked Python as a scripting language kind of got kicked out of the community because all these people that were using it for serious things were pasting weird shit into notebooks and going, yeah, this is coding. And then everyone who was saying, no, coding is real stuff, people would come in and then say, no, you can't use Python for real stuff. It's a scripting language for toy program. And all these conflicts happened because it was trying to be too many things for too many people, and the community hadn't quite figured out how to fit everyone into one box. And now they've stopped trying to fit everyone into one box. And so in many ways, as you're thinking of bringing people in, you can bring people into a community, they don't all have to sit in the same room. And that might be a better way to think about it for some cases. Particularly, I'm using this so I don't get fined. Or I'm using this and it's my job. Or I'm using this and I'm not part of the same niche and I don't have the same common ground as everyone else. They have a different common ground. And that common ground can be bridged, but maybe it doesn't need to be the same common ground.
Okay, thank you.
Yeah.
Thank you very much, Hazel. We are now in between talks, so feel free to move to another room if you're interested in one of the talks there, or stay here for the next talk in 6 minutes.
And welcome back. Next, I want to introduce someone who really doesn't need an introduction. She's in very way, she's the reason why a lot of us are here. Of course, I'm talking about the technical project manager for Bevy, purveyor of PRs, conductor of the Bevy merge train. It's Alice Cecile.
Thank you very much. Hi, everybody. It's an honor to be here, and thank you very much for that kind introduction. I've had a lot of fun. The talks have been wonderful. The conversation has been lovely, and as always, the most important track is the hallway track. So today, I'm going to talk to you guys about how Bevy does code review. We've been doing this quite differently for a number of years, and I will dive right in. Bevy had a problem. It was a good problem to have, but still very much a problem. Bevy had grown too popular too quickly. Our sole maintainer was stretched impossibly thin, and contributor PRs withered in review limbo as the queue grew and grew. People would pour hours of work into something only to wait for weeks for any feedback at all. Many of them gave up, walking away as merge conflicts grew like weeds on their PRs. But as the backlog grew, I noticed something interesting. One second. Even without formal authority. Oh, come on. Even without formal authority, people were already doing useful review work. They were asking good questions, catching bugs, suggesting small fixes, testing things on their own machines. I came from a background of science, a background where peer review was the standard way to do it. My question was, if we allow anybody to submit code without vetting, why don't we do the same thing for review? Over the years, Bevy has settled on a set of simple, permissive, and clear rules. Anyone can review anything. You don't need to be a maintainer. You don't need to be on a team. You don't need permission. If you have something useful to say about a pull request, just say it. 2 approvals from the community are needed before we mark a PR as ready for final review. Work that everyone thinks is good gets bumped up the queue for consideration. There are 2 wrinkles to this rule. First, trivial work, typo fixes, small doc comments, the things that you look at this and you're like, oh, come on, are we really waiting for a second review? They only need 1 review. Second, controversial work, stuff that has architectural implications or things where people can't stop arguing about what the right color of the bike shed is, require designated experts that make a final decision. There's something else that's important about this, where is that the maintainers follow this process themselves. This is really important for fairness, for transparency, for dogfooding it, and frankly, because review is useful. This seems like a very simple system, but we found that it works quite well. You should think about open code review as a funnel. The community review catches the obvious problems, refines the design, and builds consensus. By the time a maintainer sits down with a PR, most of the hard work is already done. Open review distributes judgment, not authority. Reviewing a PR doesn't give you the power to merge it. It says, here's what I think in a way that counts. Fundamentally, code review doesn't require deep expertise to be valuable. You can test a PR on your machine and report whether it works. You can review documentations and say whether it makes sense to you as a user. You can spot edge cases and ask about error handling and point out that an API is confusing. You don't need to be an expert. You can show up as an absolute beginner and start asking questions. And those questions are often the most revealing and important thing, and they help you get started. Bevy's process here is weird. I will not deny it. This is not how traditional open source works. In traditional open source projects, newcomers are treated with some blend of exasperation, patience, compassion, and suspicion, gradually building up trust as they submit PRs until they're eventually inducted into the trusted inner circle of maintainers. New contributors are evaluated on and taught through their code outputs, not their review quality. if you're formally reviewing somebody else's PR, it feels like butting in, and it's a social faux pas, a failure to read the room and to understand, and a misunderstanding of how open source works. Even offering critical thoughts can feel presumptuous, and it's easy to simply keep your stupid questions to yourself and walk away. Open code review turns this on its head. The single thing that we suggest new contributors do is to start reviewing PRs. But how has this worked for us in practice? It's easy to say, oh, here's this beautiful theory about how this should all work, about how people can be trusted and how this process will lead to a more robust system. But there's no substitute for experience. And there's been a number of important observations here. And with them come some caveats. The first observation is that simple work moves faster. You see things that are uncontroversial, that are well-scoped, that are obviously correct, little bug fixes, things that are clearly explained and small. And this it flows through the process. People are like, oh yeah, great, that looks good to me. It attracts quick community reviews. And structurally, this is actually really interesting because it incentivizes the work to be well-scoped and to be clearly motivated and to be uncontroversially good. And stuff that is controversial gets split out because otherwise it gets stuck in the slower, more painful queue. There is a caveat, though. Reviewers focus on the stuff that interests them. If you have horrible, tedious refactors or CI work or particularly domain-specific complex work, it can rot in review still. You need to have... People still need to beg for PR reviews. And the most tedious, but valuable work often gets stuck on people like me, people like Kurt, and you have to spend paid maintainer time on it because, I mean, that's your job. You got to do it, even though it sucks. The next thing we've learned is that work is polished before maintainers ever see it. Everyday contributors reliably catch the obvious issues. Missing tests, unclear docs, naming problems, logic bugs. This shouldn't be surprising to you. Most open source contributors are skilled professionals. They offer real judgment even if they don't have the full project context. There is a caveat, though. Authors need to be taught and empowered to reject feedback. Bike shedding is a really easy trap when you have so many cooks, and you can't allow that to halt the work dead. Scope creep, though, is the real risk. You need to keep to a standard and a threshold of better than before and meets our objective written down standards. You can't let them continue to say, oh, well, but this could be a little bit better. You could do a little more. Like, this is a standard thing from peer review in science. If you are in science, you have heard the horror stories of reviewer 2 and it says, oh, yeah, well, what about this analysis? What if you ran this experiment? And you have to say, enough is enough. This is good enough. This meets the quality bar. And in particular, as a maintainer, you have to tell the authors that they are expected to say, no, I don't care about your feedback, this is good enough, and then back them up when they do that consistently. The next one is the one that I feel most conflicted about, and it's a real challenge. As complex work moves fundamentally safer through this process. Fundamentally slower through this process, but it is safer. You have these large and controversial PRs that are being picked over by many pairs of eyes. You have the design concerns surfaced early, and you fix those problems when they are cheap. But that's an arduous and slow and painful process, and ultimately review doesn't create conflict. It surfaces it early, and the PR, in the end, is usually better for it. The caveat kind of blurs together. If everybody's empowered to critique, it's easy to create deadlock. You have to have people who are experts, who you trust, who can make that final decision and say, great, thumbs up, this is the right design. Everything else, like you can figure out the details, but this is going through. Or no, we're never going to do this. This one is the most interesting one to me. I have a project management bent, and one of the things that people talk about is the importance of the loop between user feedback and product design and product development. How do you get that working? And this code review process does a very good job actually improving that, because when you open a pull request and say, oh, it fixes issue number whatever, what you can do is you can say, hi, new user who just opened this issue. Can you please review this PR? Does this meet your needs? Can you please test this on your own machine? Can you please evaluate it directly? And it's really cool because you move the user into your review process by saying, you are welcome here, you are trusted here, you are valued. If you say this isn't good enough as a fix to your bug, we will listen to you. And that's really important culturally. The caveat here is that if you gently ping someone who requested a feature or reported a bug, it only works like a third of the time. A lot of the time, they just don't respond, or they're like, I'm not comfortable with it. And that makes sense, and it's okay. Filing an issue is a much lower investment than reviewing a PR, and it may be years between an issue and a fix. It's really wonderful when this works, but you have to emotionally accept it as a happy bonus. The last thing I want to talk about is how this has changed Bevy's culture. Policy shapes culture, shapes policy. Because of this code review process, our culture is more egalitarian. No one is above reproach, curiosity is welcome, and everyone can have something worth saying. A new contributor publicly catching a real bug in the work you, as a maintainer, spent weeks refining is humbling, and it reinforces both the value of this policy and the culture that has given birth to it. You have to be intentional about the impact of your policy on the culture and the impact of your culture on the policy, and build the systems that will shape the types of communities you want to work in. There's an important caveat for it here, and the one that I personally find the most frustrating. Because these rules apply to you, because you are the maintainer, you have to sit there and you have to wait for volunteer reviews. You have to go on Discord and beg people, hey, I did this thing, please do it. You have to go and find coalitions and say, hey, come and work with me on this stuff. And you're sitting there working full time and there's a bunch of volunteers. The urge to just bypass the review and just push to main is very real. And while you get attention faster, you have this trusted celebrity status. People review your stuff, but oftentimes the reviews are less critical than they should be. And you have to personally say, no, you have to be a dick to me. You have to nitpick me. You have to and genuinely push back against my design, and you have to give them the culture of psychological safety in order for them to do so. You should expect to work on many things in parallel. So, Bevy's problems used to be unusual. You had explosive growth that had left us with a mountain of reasonable code to review, with only a handful of experienced, trusted maintainers. But today, with the rise of the LLM, every actively used open source project is staring down a landslide of well-intentioned code, and review has become the universal bottleneck. If your review process depends entirely on a trusted core that isn't keeping up with the growth in contributors, it will eventually fail under load. There simply aren't enough hours in the day. So if you want to try open code review, start small. You should write a short review guide, making it clear about what to look for, how to give feedback, what not to do. You should tell people that review from anyone is both welcome and that it matters. You don't need to use the exact same mechanism as us, but you need to communicate culturally that this is a thing that you actually deeply value, something that you genuinely believe in, is that somebody can walk up to your project and offer their opinion and you will give a shit about it. Finally, from a practical matter, you should hand out triage rights to anybody, like just anybody. We have hundreds of people in the organization with a very low bar. Nobody has ever abused this, and allowing people to label the status of things and help out with the triage is both a good way for them to get involved and a good way to track the status of community reviews, because GitHub hates this process and doesn't think it exists. In the end, it's okay to experiment with this. If it doesn't work for you, if it fails, that's fine. You can just revert it. Code is cheap. Judgment is expensive. Ask for that.
Now it's time for some questions.
So yeah, very hype. Anyway, the common problem you've touched on with like the flood of LLM contribution generated has been overwhelming, sort of a lot of projects recently, and there has been sort of like various approaches. I think the open review has been the Bevy solution. The other one has been like these vouching systems that have been proposed, but it's like. I don't quite like them because it feels like it's raising the sort of the barrier of entry a bit too much. Yeah. So, what has been your sort of a view on these sort of like challenges?
Yeah, so that's an important question. I share your distaste for these vouching systems. I think that they're exclusionary, that they raise the barrier to entry, that they have this kind of fortress mentality that I don't think is either fitting for open source and the ethos of it, and ultimately I think is going to harm the culture and harm the approach. But it is a real problem, and that is a potential solution. I'd like to hope that the open code review is effective. Bevy has had very few problems with slop PRs compared to both Rust and Godot, which are kind of our sister organizations, each in their own way. We've had, a handful of obvious slop, and who knows how much quietly undisclosed LLM generated stuff. But it's been pretty okay. And I talk to other maintainers, and they're like, "Oh God, we're dying under this," and I'm like, I mean, it's the same as normal. You have too many PRs, and some of them are bad. Like that's always been the case. That's not new to us. The other thing that I think is important to think about when talking about AI in code is that code review is a really bad tool for checking the correctness of work. It's a good tool for building consensus. It's a good tool for teaching people. It's a good tool for sharing, starting discussions and sharing norms around how to code and building friendships. But it's not a good tool for catching bugs. It's not a good tool for catching flaws. And you need to have other approaches to that because humans are bad at this. Humans are bad at looking at some code and trying to find if there's a bug in it. You have to write tests. You have to write automated tests. You have to make them more and more sophisticated. If you're in the LLM sort, have the LLM check it for correctness. Humans are not great for that, and anything that they find is a bonus, and you should not be treating code review as a singular defense against bugs or security vulnerabilities or any of these things.
Sadly, we do only have time for one more question, but Alice is, of course, available after the talk.
Okay, I think I already have the microphone here.
Yep, go ahead.
So the thing I'm wondering is, as a core maintainer, have you run into issues where the people start reviewing the PR, and then you kind of feel forced to step in because you think this is going the wrong way and I need to steer this another way?
Yeah, so this happens all the time, and it's not just me who does it. It's people start reviewing the PR, and they're like, oh yeah, this looks great, and then somebody else will come in who has more context, who has a different opinion, and they're like, what are you talking about? Like, this is clearly the wrong approach, or this isn't the right quality level, and sometimes it'll even happen after 2 approvals have been given. And this is something that I notice in my weekly merge train, and 5% of those PRs, I need to kick it back to the authors, and more importantly, I need to kick it back to the reviewers. And every time I say, actually, this isn't ready enough, that's a signal to the reviewers that they need to do a better job. It's trust begets responsibility. It's responsibility begets trust. And as you trust people, they will be more responsible. But that responsibility means that you actually have to do a good job. You can't just rubber stamp it forever and be like, oh yeah, look at our velocity. If we wanted you to do that, we would just not have any review requirements.
Yeah. Thank you.
Thank you, Alice, for the talk, and thank you all for coming. We have a short little break until 16:20, 4:20. So you can all go down to the main level and have a snack. back, everyone, from the break. An abrupt end to the music. Anyway. Before we continue, I want to thank some of our Unconf sponsors, Unconf partners, namely Microsoft, Vectorware, and Ferris Systems. Moving right along, we have our next presenter. He worked at Mozilla and Cash App. He's currently a part-time server maintainer and a full-time dad. 15 years of Rust experience. Please welcome Josh Bauman-Matthews.
Thank you. Good to see everyone here. So, my name is Josh. I'm a maintainer of the Servo project. And Servo is the oldest project that's mostly written in Rust, apart from the Rust compiler, because Servo was a proving ground for the language for several years leading up to the Rust 1.0 release. Servo is a rendering engine for web content. It's not a web browser. It's just the part of the browser that shows you the web page. And I've been working on it for 14 years. It's grown pretty complex in that time. There's about 350,000 lines of handwritten code that's only used for Servo, another 250,000 in some of our most popular crates, and another 700,000 lines of code that's generated as part of the build. And really, the purpose of all this code is to make it as easy as possible to embed web content in a Rust application. It should be interactive. It should be performant, but most of all, it should be safe. This is 2026, and we can dream bigger. But wait, you say, why is it only mostly written in Rust? Can't Rust do anything? Why do you even need another tool in your toolbox? So, one of the things about building a web rendering engine is that the web platform is absolutely massive, and compatibility with existing web content is a really hard problem. So in Servo, we've prioritized writing code in Rust where a new implementation can make a big difference to either performance or safety. And we've adopted existing libraries where it was helpful to make progress quickly. So for example, we reused Firefox's JavaScript engine, SpiderMonkey, because Servo was a project that started at Mozilla, and we wanted competitive JavaScript performance. Given the motivation of using Rust for Servo, we're really sensitive to reports of crashes. Inevitably, these can be traced to either a bug in one of these libraries or the Rust bindings that we've created for them. Now, our story starts last December. There was a WebAssembly version of the game Diablo 1 that was published a number of years ago, and it works great in other browsers. So someone decided to test it out in Servo, since we theoretically support all the things that it needs. And we always like flashy demos that we can share on social media. What we got was not a very flashy outcome. This was a panic in the Rust bindings to the JavaScript engine, claiming that we're trying to dereference a misaligned pointer. Now, when there are crashes that involve nonsense pointers like this, I usually suspect that our integration with SpiderMonkey's garbage collector is subtly broken. We've had all sorts of platform-specific bugs around calling conventions and C++ virtual table representation. And these are just the risks of using Rust to wrap a modern C++ API like SpiderMonkey. So we didn't have a lot of information to go on yet. The issue report mentioned that the crash was reproducible in release builds, but not debug builds, unfortunately. And that was annoying, because you get worse backtraces, you get worse behavior if you're using a debugger, and release builds take a lot longer than debug builds. So additionally, triggering this crash required downloading a 40 megabyte WASM blob every single time, which wasn't great for iterating quickly. So starting from an unminimized reproduction like this requires teasing out which details are important. So usually, enabling the debug assertions in SpiderMonkey will help with this by uncovering the problem sooner. But this time, it didn't actually make any difference. We still got the exact same error message. So that meant it was time to bring out the big guns. So SpiderMonkey decides when to collect garbage using heuristics about how many allocations have occurred, how much memory is allocated. This means that any changes to the test case can affect when the garbage collection occurs, which could actually hide the crash. So to avoid this problem, SpiderMonkey also has a mode that performs a garbage collection after every single allocation. This is called the zealous garbage collection mode. And it's really, really slow, but it will reliably identify the first time that a garbage collection related bug is observable. And that's a very helpful property for issues like this. Now, this mode was so slow, it actually ran continuously for 3 days on my laptop, which got really hot during that time. And eventually, it panicked, but in a way that was completely unrelated to the problem and gave me no new information at all. That was really frustrating. So I decided to look more carefully at the crashing code to see if there was anything suspicious. The crash backtrace showed that the problem was occurring in our generated JavaScript engine bindings. So apparently, one of those 700,000 lines of generated code had a problem. Some JavaScript is being run that called the data getter on a message event object, as we can see from stack frame number 3 here. And we crashed before returning from the generated code. So it was time to crack open the hood and see what was wrong. Now, this is a simplified version of the crashing code. This is a function that's called from C++. So where's my cursor? There we go. So it accepts a immutable reference to our message event Rust type. It invokes a method on it. That gets an associated JavaScript value and returns that to the caller through the out parameter that's named out. So a message event object can have an arbitrary JavaScript value associated with it, and the data getter method returns that value. Now, one thing that looks weird here is this rooted macro here. This creates an instance of a JavaScript value named value in a stack location that the garbage collector can observe. So our getter here then places a copy of the internal value that it holds into that stack location through an out parameter that, where'd the cursor go again? It's on the S. On the S. Oh, it's not, oh, I wasn't touching the trackpad. Okay. Yeah, so our getter then places a copy of the value into that stack location through the out parameter right here. And by calling this handle mute method, we provide a mutable handle argument so that the method can mutate the value within it. And then finally, we convert our JS value to a JS value, which should be a no-op. But we place it in the location that the JavaScript engine expects to see a return value, namely inside the out argument here. And the crash occurred in the final conversion operation because we didn't actually have a valid JavaScript value in our stack slot. So that points the finger at the message event implementation. So let's take a look at that. However, the implementation of the data method is about as simple as it gets. The message event has a member that it copies into the out parameter. Everything is written the way it should be. So maybe the value is bogus when we construct the message event. But once again, everything looks normal here. The constructor receives a handle to a value. It copies the value into the member, and then returns the new message event. Nothing looks out of place. So maybe the value is bogus before the message event is constructed. So I set breakpoints on all the places that create message events to allow me to find the one call site that actually mattered. And once again, in this code that created it, we're following the correct patterns. So this code receives a serialized JavaScript value, which is called a structured clone. And then using the rooted macro again, we declare a stack root to store our new JavaScript value. Then we deserialize our structured clone and put the result of that operation into our stack root using a mutable handle. Finally, we pass an immutable handle to our stack root to the message event constructor. So everything still looks fine. So I tried adding debug prints that would show me the pointers involved that were encoded in this JavaScript value, and there were no crashes when I tried interacting with those pointers. So this was very mysterious. Now, I keep using the words stack root and handle, so we should talk a little bit about how garbage collection works. So a garbage collector maintains a set of roots. These are values that are protected from being collected. You can think of them as being the roots of a tree. So most roots will live on the stack. The values inside them are only eligible for garbage collection after the stack root is dropped. So I've got a little diagram here showing what this might look like. When a collection occurs, the garbage collector will start at the roots and traverse all the values that are transitively reachable from them. Any values that are not reachable can be collected. So here we create 3 JavaScript values and we give them names, A, B, and C. I've given these names big black outlines here to show that they're roots. If a garbage collection occurs right now, none of them would be collected because they're all reachable from known roots. So I've changed the code sample now to use an anonymous function in JavaScript, where we only return one of the values to the caller of that function. So now there's only one root, the obj value here. And if a garbage collection occurs, we can see that we start at the root, and we can reach B, and we look at the value there, and we can see that we can reach A, and there's nothing else to reach from there. So none of those can be collected. But C could be collected because there's no references to it anywhere. It's not reachable from any root. Now, the other thing we should talk about is the SpiderMonkey's generational garbage collector. SpiderMonkey has what's called a nursery. That's something that is cheap to allocate and clear. And it's a performance optimization for JavaScript values that don't live long or are really small. And the point of a nursery is that when a garbage collection occurs, any value that survives that collection then gets moved out of the nursery into the main heap, which means that any pointers to those values need to be updated. So in the original diagram, we had two strings in our nursery here, and 2 roots pointing at one of those strings. And you can imagine they have a pointer of like 0x01. Then a garbage collection occurs. The one string gets collected because it wasn't reachable. The other string gets promoted, and we have to rewrite the pointers for both of those roots to look at the new location for it now. The other thing we should talk about is handles. So to support that pointer rewriting operation, SpiderMonkey's public API requires handles to rooted values instead of the values themselves. And this is a way of ensuring through the type system that the garbage collector can always see the full graph of values whenever it needs to rewrite pointers. And this is just a C++ class called handle. It takes a generic argument and stores a pointer to a value of that argument inside of it. Now, in Servo's Rust code, we have a handle type as well, but it's a little bit different than the C++ one. The C++ ones are possible to misuse because they're just wrappers around raw pointers. And there's no relationship encoded between the stack root and the handle to that root. So a root could be dropped while the handle is still live. And that sounds like a problem that borrowing and lifetimes can fix. So in Servo's code, we use a separate Rust handle, which includes an immutable borrow of the rooted value. So back to our investigation. I had determined that all of the code related to message event and its data member was using stack roots and handles appropriately. Now, at this point, I remembered I was not dependent on the whims of the JavaScript engine's heuristics. I could trigger garbage collection operations manually to narrow down what was going wrong. So what I learned was a bit baffling. I duplicated the code that was crashing before and after every time I called this JSGC function that would trigger a garbage collection. And it was easy to make the engine crash as a result. So then I tried printing out the information about the pointers again. And the pointers never changed, but it did crash. So I still wasn't sure what was happening here. But with being able to trigger the crash now, it meant I could construct a much more simple test case. All we need was a web worker that we could communicate with. We then use post message to send an empty object to the worker. The worker will receive that message and then deserialize that empty object and construct a message event from it. And it was this empty object that was having a bad interaction with the garbage collector. So if the pointers aren't changing, there are two possibilities. Either the garbage collector is overlooking my stack root, or something during the garbage collection is invalidating what it's pointing to. So I used a debugger to confirm this hypothesis. I set a breakpoint on every garbage collection operation, and then printed the pointer value before it occurs. And then I used a hardware breakpoint to set a watch point on the memory that was being pointed to, which meant that any time the JavaScript engine would overwrite the values there, the breakpoint would trigger, and I would be able to observe what was actually overwriting that value. So this worked perfectly. The hardware breakpoint showed me that the bear object wasn't being collected, but it was being moved out of the nursery somewhere else because it survived the garbage collection. Now, as I said, SpiderMonkey needs to rewrite any pointers when this happens because the allocation now lives somewhere else. So why were the pointers still the same in my debug prints? So Servo's been around for a lot of Rust's lifetime, and we have reported our share of compiler bugs and miscompilations. It's really tempting to look at this and blame the compiler, but I wanted more evidence. The code was using stack roots correctly, so the garbage collector should be able to rewrite our pointers. The code was passing handle values around correctly, so there shouldn't be any secret values that the garbage collector can't see. So it was time to step through the pointer rewriting code in SpiderMonkey. So I needed to write down the address of the only Rust stack root, then set a breakpoint on the nursery promotion code that would loop through all the known stack roots and update them if necessary. And when I did that, I watched the C++ code find the Rust stack root, see that it needed to be updated, and then update it with the new pointer. Great. But then printing the value from Rust still showed the old pointer, and my brain exploded. So this is the essence of the Rust code that was printing the pointer. We have our handle type that contains an immutable borrow of a JavaScript object pointer. And when we print, we dereference the borrow to get the object pointer. Great. That all looks reasonable. But by using an immutable borrow, we promised that the borrowed value wouldn't change while it was borrowed. Then we went ahead and broke that promise. So what does that actually mean for our program? What is the compiler allowed to do in response? This is a Rust program which is equivalent to what we were trying to do. We store a rooted integer in a stack slot, and we keep a mutable raw pointer to that value. Then we create an immutable borrow that is live while we perform a garbage collection operation by changing the value in that stack slot. And then, when we dereference the immutable borrow again after the GC operation, this is undefined behavior. So the compiler assumes that undefined behavior is not present. We could imagine the optimizer transforming the program to avoid dereferencing the shared borrow twice. I mean, that's obviously faster. And why wouldn't we want that? You do want your program to run fast, right? There's a super useful tool called Miri that's designed to catch problems like this. It interprets your Rust code, it checks if it performs undefined behavior, including violating borrowing rules like this. And this is an error message from Miri. If you haven't seen one like it, you're either not writing enough unsafe code, or you should be running Miri more often. So Miri doesn't like the minimized program that I just showed you. It tries to tell us what's wrong, but it uses some confusing words. Thank you anyways, Miri, you're doing great. So the handle and mutable handle types originated in SpiderMonkey, where they provide type safety for APIs that could write new values to the rooted value. This was a false promise when we translated this into Rust concepts, because the engine could also write new values to the rooted value, even when the API only accepts a non-mutable handle. This puts us in conflict with the rules of Rust. So many discussions about undefined behavior feel theoretical to me, where people will look at some code and say, that's not allowed. but the code seems to work just fine. And that's always frustrated me. Like, I want to know what can actually go wrong. So I found this investigation really helpful for the way that it shows the relationship between undefined behavior and compiler optimizations. The compiler saw an opportunity to skip dereferencing the handle because it had already done that before. And there was obviously no way that the value could change. After all, we promised that that was true by using an immutable borrow in the first place. So some lessons that we took away from this. If we use raw pointers, then we don't create the borrows that can lead to undefined behavior. By using phantom data, we can still have the lifetime that prevents the handle from outliving its rooted value. So this is something to consider for any project where you want to model a lifetime relationship with a value that could change in ways that you don't control. Another thing is that we needed to remove the ability to expose an immutable borrow like this. In this case, having a deref implementation for our handle types made it too easy to create an immutable borrow that can conflict with a GC operation. We can't create a safe Rust API if we can't control this property. But luckily, there are some very clever people working on Servo who have decided to solve this problem. So we've built a system for our JavaScript engine bindings where we can use Rust lifetime rules to statically guarantee that garbage collection will not occur. And we can get this in our type system with this noGC argument here. And so given this property, we can now expose immutable borrows safely for as long as that guarantee holds, based on the lifetime here. And therefore, this gives me a lot more confidence that we won't accidentally introduce this particular problem again. Another lesson is that Miri is great. I'm so glad it exists. It's a valuable tool for uncovering issues like this. And it's easy to plug into your CI and local development workflows, which is really important. However, it doesn't work for Servo because all of our risky code uses FFI, and Miri doesn't support FFI calls right now. Now, I have learned that Nia is committing all kinds of computer crimes to make this possible. So I recommend watching the talk that she gave this morning about that topic, if you missed it. But I think it's still safe to call it an early experiment at the moment. And like, we could write equivalent Rust programs like the one I showed you earlier, the minimized all Rust one. But then you have to trust that like the translation that you did matches what the actual real code is doing and keep it up to date over time. And I don't think that's realistic for our JavaScript bindings. So I guess we just have to use fuzzers and a giant test suite to catch symptoms of undefined behavior. And then as long as we think really hard while reading and writing code, we can avoid any more problems. That sounds like a scalable solution. So honestly, after the initial rush of excitement, when I figured out that we were triggering undefined behavior, I felt kind of bummed out. It's not a good feeling to wonder if there's undefined behavior lurking in every dusty corner of the code base. Oh well, that's the job. Thanks for coming to this talk. Just kidding. Okay, so after my initial disappointment, I went searching to see if anybody was looking into the issue of Miri and FFI things. And I'm really excited about the Borrow Sanitizer project, which started as a research paper in 2024. And they're actively working on detecting Rust aliasing violations with FFI code. And they're funded by the Rust Foundation and Google. So it's built on a new Clang pass that instruments Rust and C++ code with extra metadata, a lot like the way that Address Sanitizer is implemented. So it doesn't have the same kind of performance limitations that Miri does. They're still working on passing Miri's test case, or Miri's test suite right now, but they're planning to integrate like a test case for this problem from Servo, for example, and they've made it really easy to test out their in-progress work. So I'm following along closely. So on that note, if there's any other prior art out there that I missed, I'd love to hear about it. And if you want to come up and swap horror stories about using unsafe code with me, that's also fun. Please come say hi. I'm always happy to talk about Servo or help people make their first contribution. Thanks a lot.
Thank you, Josh. Let's open the floor for questions. Any questions? It's hard to see. Yeah, question here.
Thank you for your talk. I have a question on the use of phantom data. Near the end of your presentation, when you showed the fixed version, why do you use phantom data of a reference to an empty tuple as opposed to a reference to T?
Because I don't actually know what the difference is.
I think it's something around how it behaves with regard to variance, depending on how your value is variant over T. So depending on if T is variant, phantom data of reference to T will also be that way. But if you use a reference over empty tuple, it will not depend on that. So I was wondering whether it was like a conscious choice or whether it just doesn't matter in this case.
I think I chose it out of fear, probably. I hear the word variance and I break out in a cold sweat.
Understandable, thank you.
I can quickly answer the question why unit instead of T. It doesn't really matter. The purpose is to bind the lifetime there. So you can basically put any type there if you want, as long as the lifetime is there.
Thank you for the talk. Does Diablo run now?
Sorry, what was that?
Does the Diablo version website run now?
It doesn't crash. It plays sound. There's a sort of big black box, though.
So I try Servo now and then, but I guess I really need my browser plugins. When might they work?
I don't know. That's a big. There's a lot of pieces that are hard before we get that far. Like, yeah, browser plugins are complicated because you really want to write them in a way that doesn't allow them like direct access to the page internals. Otherwise, the page can, if the add-ons work at a higher privilege level than the page, then the page could get access to higher privileges, and like you don't want that. So you need a level of security in there, and so like we're just not implementing anything until we can actually do it like right.
Okay, well, thanks for Servo.
Hi, we were like looking at test 262 earlier, and I was wondering why is there like any plan to move to, for example, Boa as your JavaScript engine instead of SpiderMonkey?
So there is desire, not necessarily instead. I think there's desire. Personally, my desire would be to make it a configuration you can choose, and you don't. Like the performance difference between Boa and SpiderMonkey or one of the other established engines is like they're not comparable at this point. And so I'd love to be able to give people the choice between accepting performance limitations while also reducing the potential attack surface of the browser by using a different engine, or choosing all the performance you can get. Unfortunately, it's very difficult to figure out what the right abstraction layer is to allow that. So like the desire is there. It's hard to prioritize that over making general web compatibility work right now.
Hi. I want to circle back to web extensions a little. Follow-up question, if I may. You mentioned that it's hard because it requires a lot of security layers which are not there. But is it possible to hook into Servo and write kind of extension-like stuff in Rust? So not web extensions, but hook into the engine and do.
Are you imagining like defining a new property that the page could access that like calls Rust code or something?
Something like that, yes.
Not at this point. That's another thing where we don't yet have a good story. Like we don't yet have a good story for allowing like defining arbitrary Rust code that can be built outside of the main like servo build, because we have a lot of like static checks to prevent using the JavaScript engine incorrectly that don't run by default for people who are like using servo as a consumer. So we want to support that. That is a use case we want to address, but we're not there yet. What you can do as an embedder right now is like evaluate JavaScript in the context. Like you can choose to evaluate some JavaScript in the context of the page content and get responses from that asynchronously or synchronously if you want. But that's as far as we've got right now.
Thank you.
Are there any further questions out there?
So the bug you showed was kind of scary, and especially the part where if I would look at that code, even maybe the simplified version that you showed, I'm not sure I would be able to catch it. Do you have any advice for like, with especially hairy, tricky cases like this, how to figure out that actually something is going on that is wrong?
I mean, yeah, that's the problem. Like this kind of stuff is latent until it's observable in some way. That's why I'm really banking on the tooling from Miri and Boro Sanitizer, because until then, like it really feels like here be dragons. Unsafe code is just a continual lesson in humility.
I see no further questions. Oh, there.
Sorry if that my question is tangential to your talk, but have you looked or tried Node.js C stable APIs for working with engine as a kind of a, layer between server and JS engine? And they had also built like Neon, and I forgot what the name of the second one was, Rust wrappers over those layers.
I have not actually looked at those. Yeah. But I mean, I've heard also recently that like the way the WebKit integrates with their JS engine has a sort of interesting abstraction layer too, which I think there are definitely some layers we could use for inspiration here. That yeah, I appreciate the reminder.
Yep. Yeah.
Hi, thanks a lot for the talk. If I understand correctly, Rust was kind of not really chosen for this project, but the other way around, to be the playground. And I've been following the developments in another browser recently where they tried Rust with Swift, didn't like it, but then they liked it again. Now there's RustNet. And I also heard that from the main maintainer that it'd be great to have garbage collector in the language you write a browser in. I would like to hear your opinion on how Rust is for such a project. What are some unpopular things you'd like to have in Rust, or what language would you pick?
I mean, I do think Rust is the right language for this. I think starting a new browser in a language that isn't Rust, you need a really compelling reason for that. I think the thing that it's a weird match for is that the way that the web platform is implemented is that like shared mutability is everywhere, or shared ownership. So unfortunately, that means that like all of the implementations of JavaScript APIs in Servo are done with like immutable self, and you have cells and ref cells everywhere, which is really annoying because it's nice to be able to make use of. It would be nice if we could make more use of some of the benefits of Rust type system, rather than pushing everything to runtime and encountering dynamic borrow failures, which also have fun interactions with garbage collection, which we call borrow hazards, which is just like a whole nother way to panic at runtime in rare cases that are hard to track down. So I mean, I wouldn't prefer to have a garbage collector in Rust, because then we would be trying to mix two garbage collectors, which actually sounds worse to me. So I don't know. In our case, we actually just there's a blog post from years ago where we talk about how we use the garbage collector from SpiderMonkey to actually control all the memory or a lot of the memory in Servo, and there's some fun things there. So I wouldn't necessarily want one in Rust itself.
Okay, thank you. So once again, we are in between talks. Next up will be the final talk. So feel free to move into another room if you're interested in one of those talks, or stay here for the next one. See you in 8.5 minutes. Okay, let's get started. Please take your seat. Our next speaker is Eva. Eva is a former US advisor on open source security policy, now runs a boutique cybersecurity consulting firm, founded OpenSec Ironic long ago, but most of all loves riding motorcycles. Give a big hand to Eva.
Hi, folks. I know that I am almost all that remains between you and snacks and drinks, but I'm really happy you're here. I want you to come away from this talk knowing that you are empowered to help bring about positive change in open source and how open source is connected now to, good gosh, the whole world. But I'm going to tell a few stories, and I also want you to start telling stories. Whether you're new to Rust or you're an old hat, telling stories is how we as maintainers, as community leaders, as individuals, how we change the world, how we inspire others, and how we pass on our community values. Stories help to contextualize our role and inspire each other. So I want to tell a little story to start about accidental policy, because I did not start my career thinking I would ever get into cybersecurity policy or geopolitics at all. I also never finished a degree, though I've tried 3 times. I keep getting distracted by writing code and solving other problems. But in 2022-23, I was working at Microsoft. I was doing work around open source strategy for helping the company figure out how to, do some good. That's what I keep trying to do some good and get organizations to help. And I got invited to give a talk at an event called ShmooCon. Long live ShmooCon, it's gone now, it's over. There will be no more, but it was a space for hackers and public policy and just companies to come together and talk about cybersecurity in Washington, D.C. It's a little event on the side put on by some folks called Hackers on the Hill that started to try and connect people from the folks who write law and the folks who break code and get them to, see eye to eye and make things a little better. They invited me there. I asked questions that were uncomfortable for people, who then invited me into a small room in a very friendly way to take a look at what was then the unreleased draft of the National Cybersecurity Strategy. And I said, gosh, you say open source in here, but you're saying it in kind of not the right way. Because the responsibility for software, for cybersecurity at large, should really be placed on the shoulders of those capable of fixing these big problems, not on volunteers, not on individual contributors, not on nonprofit communities or open source developers. And this is actually a quote from the official strategy that came out months later. They published it, then they called me up and said, hey, so we took your advice, now come do it. Oh, shit. And so that's how I got into the role I had for about 2 years, working in the US government, trying to make open source security strategy part of the national strategy. But how did we get into this situation in the first place, where it was even something that a national government would consider and would care about talking about open source and what we do? Well, the tech industry spent a really long time moving fast and breaking things, and kind of combining that with profit-driven hype cycles and ignoring regulations, and that led to a lot of things breaking really badly, and then congressional hearings, and yeah, that whole situation. When open source was just someone else's problem and no one had to notice it, we all got to just be our delightful selves. So I'm going to go way, way, way back to when I was in college and playing video games and studying physics and philosophy. And then the Copyright Act in 1999 got passed. And I thought, this isn't great. I can't send files to my friends anymore. And that was the first code I ever published back then. I then tried to make a less bad ad company when I thought ads were not terrible. They're kind of terrible now, I'm so sorry. And then I did some work on databases because I thought it was not great that Oracle and IBM charged every single company tons of money to run a database. And if you wanted to start a small business, you needed a database. If you wanted to run a website for your community, you needed a database. And I wanted those to also be available for communities to run for free. So I did a bunch of work with open source databases. And then clouds happened, and I did a bunch of work trying to make clouds open source, and then containers and Kubernetes. So all throughout this, I've been trying to make open source technology available to do the things that communities need. And while I was leading OpenStack Ironic, I was also working at a big company. I was at HP Cloud, Hewlett-Packard. The sales lead, I went to speak at a conference like this. And my regional sales lead was like, hey, while you're in town, I want you to meet some customers. I'm like, sure, you flew me across an ocean. Fine, I'll meet some customers. But the last customer of the day walks in. And I've been in this routine of like, I'm the open source person in the room, just telling you about open source and how to use the tech. And then I look up and it's a 2-star general. And they close the door and my salesperson's not in the room anymore. And that was really awkward. And after that, I started reflecting back. That was at about 12 years in my career. I started reflecting back on all the times I had seen governments show up in tech conferences. The NSA talking about their use of large clusters, the US Navy talking about their use of databases. Like, this isn't just a bunch of internet hippies making cool tech anymore. We've been building stuff that everybody uses and everybody relies on. And, well, this is an old rule that organizations which design systems in the broadest sense of the term of system are constrained to produce designs which are copies of the communication structures of those organizations. That was said about companies. And it's a criticism of the poor quality code a lot of companies ship because they don't think about the structure of their teams. From a long time ago, more companies nowadays do think about that. But open source communities also very consciously have, at least in my interaction with Debian, and Apache, and OpenStack, and Kubernetes, and now Rust, open source communities also intentionally organize the shape of their teams and their governance, and the code you produce reflects that organizational decision. Hazel gave a great talk earlier today on culture of inclusion and how that affects the output of the code, and vice versa. The nature of the code affects who wants to participate. This is also true of other projects. It's true of humans. It's also true of countries. This is Conway's law, and it affects all of us. And I want you to think about, as you, Rust community, are growing, how to embed your values into the shape of the governance of the project, of the companies you work in, and the interactions between them. But to talk about today a bit more in the messy spot we're in with cybersecurity, I need to go way, way back in time, and I'm going to try and run through this pretty quickly. But I also want you to remember what I'm going to share in the next 5 or so slides is not ancient history. It's history that I remember, except for the very first slide. People alive today who help lead some of the open source communities you know, this hasn't always been this way. It's been built in our lifetimes. Way back when. Anybody, I can't see hands in here, unfortunately, but how many of you know the movie Hackers? I can hear the hands going up. Great. So yeah, if you weren't alive back then, like it's dramatized for a movie, but it kind of was like that. It was really fun. And that's also roughly when I was in college. And it's really cool to see like my queer-ass self reflected on a big screen with a bunch of nerds on roller skates and keyboards. It's good vibes. And a lot of institutions that we know today were founded in that era, in that culture, and they still exist. And they've kind of defined a shape of things. But these are not ancient history. They're not written on stone tablets. This is our lifetimes. And then end of the 90s, early 2000s, does anybody remember this T-shirt as a weapon, as a slogan? A couple hands. This was a slogan that came out of a set of lawsuits around the right to publish cryptography without being labeled and having to file forms with the government saying you are exporting a weapon when you're just writing mathematical functions in machine code. Thankfully, the government backed off on that, and we have now OpenSSL as a direct result of the Bernstein lawsuit in America. We also have the LAMP stack, Linux, Apache, MySQL, PHP, Perl, Python, that grew out of that and enabled e-commerce and the entire web as we know it. Unfortunately, also a few very large companies that contribute to open source, but also use a lot of open source. We had the whole 2008 crisis and a window of like kind of stability before then, but also in 2008, something very essential happened. The first acquisition of an open source company for $1 billion. And then all of the investor class in Silicon Valley took notice and were like, oh my gosh, I need an open source strategy because they just made $1 billion. I need to get in on that cash cow. And suddenly every company, every startup needed to have an open source strategy. Bitcoin dropped, Android dropped, both open source. And 2008, we see a structural change and pivot in the industry's engagement with open source. 2010s, everything got cloudy. Thank you, Amazon and Google. I spent a bunch of time working on OpenStack and Kubernetes back then. 2015, GitHub got acquired by Microsoft. And this changed open source yet again. It even further institutionalized and normalized open source as just how business does business. And, well, there was also some issues I take with some of that time period, because back then GitHub didn't have the ability to handle CVEs or private bug fixes, private vulnerability fixes for open source projects. And a lot of things had to be learned again by new developers or people new to open source. And now, well, open source is everywhere. I think we heard in Greg's keynote this morning how it's like literally in every device around us, from projectors to light bulbs to washing machines to satellites. Open source is in every product. Younger me dreamed of the day when open source was everywhere. So I think it is ethically how we do better as humanity when we work together. So it is a more ethical choice to do some open source. However, I have to ask, is this success? Why then does it feel like everyone I know is burned out or out of a job? Or terrified of the coming vuln-apocalypse when Glasswing is detecting new vulnerabilities in every open source project, and we're all going to get, crushed under the oncoming avalanche of vulnerability reports. This isn't great. This isn't sustainable. I've been trying to address this for a while and trying to motivate people to address this. So a couple years ago, I wrote a long blog post. I just pulled a little clip out of it that vendors are incentivized to keep open source less secure, less operable, less feature-rich, less observable, precisely because they sell products that do those things. It also means, and I know so many developers over the years who were told by their managers, don't push that fix upstream, keep it in the product. Companies are incentivized to keep open source slightly less so they can sell more product. This isn't good for the commons, and this has led to a crisis. Governments are thankfully slow to react. It would be not great if they were trying to cut us all off before we do cool things, but they have responded now. And after a decade of externalized risk, companies pulling more security into their product and leaving the commons unmaintained, we have things like Heartbleed, a vulnerability in OpenSSL from a decade ago, LeftPad, right? Hopefully, these are not unfamiliar terms to everybody in this room. Log4Shell, anybody else lose Christmas over that? Peace Not War was an awkward moment because I want to support people who speak up and try to use the access they have to make the world better, but this allegedly caused harm to people in hospitals in Russia when open source maintainers took their project and tried to use it to protest Russia's invasion of Ukraine. And the Red Cross had to respond to this situation by making a new international guideline that says, don't do that. And then, of course, exeutils. If you don't know what exeutils is, essentially a social engineering campaign seemed to pressure a developer, a maintainer of a little compression library that's used in Linux and everything, to plant a backdoor in Linux. Thankfully, it was caught by a totally unrelated team of people who noticed it and prevented, but it was high enough visibility that world governments suddenly realized, oh gosh, other governments are trying to undermine our open source, and open source is in everything, so we have to do something. That's not great. And this isn't new. What is new is that 20 years ago, when bad things happened in our little corner of internet hippies and Usenet and IRC and open source idealists, those bad things didn't affect the entire world. They didn't put critical infrastructure or trains or hospitals or water at risk, and now they can. So government reaction was inevitable. Here in Europe, we now have something called the Cyber Resilience Act, passed a couple years ago. The first obligations go into effect this year. The penalties, pretty major fines, can start end of next year. I was not successful at implementing these sorts of things in the US, though I tried, but here the European Commission has done stuff. And the CRA creates a legal obligation for every manufacturer who puts a product with digital elements on the European market to, make it secure in certain ways, but also critically to contribute back to open source. If the manufacturer finds a vulnerability in an open source component they have used, they are going to be obligated to notify the project, and if they fix it in their product, to share that fix with the community. The community doesn't have to do anything with us. They don't have to incorporate it, but it starts to tip the balance back a bit and get companies to help support open source by law. This is a fundamental shift. Relationship between upstream and downstream. Now, it does not regulate individual developers. I want to reaffirm that for everybody in case you've heard any other statements on the internet. As an individual maintainer, zero effect on you. It does create a new category of legal entity called an open source steward, and it applies a light touch and tailor-made regulatory regime. That's actually the words in the law. No fines, but some legal expectations and obligations for stewards. If you're asking yourself, are you a steward? Well, if you're an individual developer, you're a person, you're not. If you also own nonprofits, if you own a company, then the legal entity might be a steward. How do you know? This is a bit weird. The law actually uses duck typing. If it looks like a steward and it walks like a steward and it does certain things, then it might be a steward in some cases. And this is a little awkward, and they published some more clarification around it. I'm not going to dive in. There's a helpful flow chart the commission put out. If you really need to know, you can always call me later. But the expectations for stewards are pretty lightweight. A healthy open source project probably already does these things. You have a vulnerability handling policy, somewhere for people to send bug reports. You have a channel to push out updates and share those with people, and maybe a little documentation. And the last one's maybe the hardest, or sort of, not hardest, least currently normal, common practice of notifying your national CSIRT, Cybersecurity Incident Response Team. Basically, your country has a public body, part of the government, that handles things that affect the code that runs power and water. If you're a project, foundation, or a company that maintains open source and you have a major vulnerability, you just notify them by, filing a CVE report and publishing it. The end. It's really lightweight. Don't worry too much. The part of this that makes me most excited, other than the new obligation for manufacturers to participate with upstream, is the potential through a delegated act, which means they haven't written it yet, they might create a better mechanism to require downstream commercial users of open source to actually help fund the maintenance of that open source that they depend on. They might do this. Fingers crossed, I hope they will. I'm not going to go too much into the details of that, because that is its entire own talk, or paper, or book. It's going to be long. But it's not currently defined. So, you. Unfortunately, I still can't see your hands, but I want to ask, by some measure, I guess raise a hand or do a little noise like that. For how many of you is this your first conference? Almost nobody that I can see. Well, then the next thing I was going to say, maybe it won't connect as much, but I want to let you know, if you're new or if you're on the live stream and you've never been to a conference, I was also terrified at my first conference of so many people I didn't know. It looks like I'm not a walking suit full of bees, but I genuinely, even though I've been doing public speaking for 21 years, still have stage fright, still super socially awkward. This is a super welcoming community. Try and talk to people. If you don't know anybody here, you've now seen my face. That works way better at the beginning of a conference than at the end. How many of you write open source because you want to make things better? Okay, almost all the hands. Fantastic. I like to think people do open source because we're idealists, and this is especially true in a community. We care, we want to make things better. Some of the other talks today were about this division between people who participate in community because they want to versus people for whom it's just a job. And that's fine. It is hard to get a job writing open source full time with funding to travel to all the conferences, but like, yay us that can. And how many of you, because you want to make things better, have also volunteered in some way with a public body, like your local election council, or you've sent in a comment to a governmental request for input? Ooh, a couple hands. Awesome. Well, here's the thing. Especially right now, world governments are paying attention to open source. They want to hear from you. Whether it's through lobbying or activism or responding to a governmental request for input, a request for comment on a draft, or going and volunteering with a think tank or a group or a company. And even in those of you who work in big tech companies, they all have an internal lobbying body. They're usually very supportive of the engineers participating to make better policy. And then they can pass it up to governments. Because right now, really every world government either has an open source strategy and they're working on polishing it, or they're trying to build one. So even if you're not in Europe and not in the US, you can get involved. I guarantee you your government is noticing open source and wants to understand how to be better and safer and participate in this, not stop it and not over-regulate it. In Europe, there have been a number of Have Your Say initiatives. This is the link to the sort of overview page, and you can filter on it. And as an individual, you can just subscribe and then send a comment in. It's not that hard. It's not that scary. But if you say things that they're especially interested in, they might call you up, and they might ask to hear more of your ideas. Because if software reflects institutional policies, Conway's law that I mentioned earlier, then policy is the software of institutions. And if you want to change the way institutions work, you can learn how to modify their source code. That's what I've spent the past 10 years doing. It's messy, it's different. A lot of it isn't written down, and what is written down is not written down in Rust or C, but in legal jargon and very specialized terms. But once you learn to see it like a programming language with types and variables and pointers and references and a commit history, it might start to make more sense. And then you can see how to unwind it or how to make one small change that has a ripple effect on other parts of the program. And I think that's really cool, and I hope my talk inspires some of you to get more involved. Because I want to close with a quick epilogue. AI is on everyone's mind for a lot of reasons, and it is built from the collected, published, stolen, creative works of humanity, especially open source. Right? AI is trained on so much of our code that we've written over the past 30 years. But models are not intelligent, and they are not artificial. They are spicy statistics, stochastic parrots, lossy compression of copyrighted works whose creators are too big to hold accountable for that theft. They are, however, capable of augmenting human intelligence in some powerful ways. And really easy to get wrong, but useful if we can get them right. In the presence of these tools, for better, or regardless of what you think of their ethical nature, the presence of these tools is fundamentally reshaping how we interact with computers and with software and with each other, sometimes making things much worse. So I want to zoom way, way, way out. Imagine the time warp effect in ancient history. It took years to memorize a book by oral tradition. The cultures we now know about were those who invented writing. For thousands of years, writing was done by hand to propagate knowledge, and then the printing press was invented a few hundred years ago, and that fundamentally reshaped the distribution of information, leading to major social upheaval. Radio and television, again, changed the information propagation landscape, and propaganda over the airwaves crossed borders, across walls, and changed regimes. Social media created yet another asymmetry, an algorithmic influence that enabled new forms of organizing and new forms of oppression. Our world right now is still in the upheaval from the invention of social media and the digital realm, and yet another one has come on the scene. This thing we call AI, which not only propagates information at a much faster pace, a much higher scale, it propagates bias hidden in it, meta-information. It is much harder to identify and defend ourselves against. But the practice of co-creating and sharing knowledge and culture across borders is as old as humanity, and that's what we do in open source, the same thing that open science cultures did before us. However, this phase change, this information propagation asymmetry, every time it has happened in human history, it has led to social upheaval. I think we are in for a rough time. And a lot has changed since my advisor in 1998 introduced us to neural networks in university. We've had multiple AI hype cycles since then, and even one before that. But this feels different because now they are useful, generalizable, and everywhere. And the moment that I had an epiphany about the potential for this was actually 2019. I was at a conference, I was asked to envision a future for sovereign cloud and the potential for AI in sovereign cloud. And I said, I want my own hardware at home, and I want a little communicator-like Star Trek device or something that can travel with me and carry the last layer training of a common model, plus my data. So I can do local voice translation, local augmentation off my data in any cloud in the world without giving my data to somebody else. We now have the tech. We could build something that cool that protects individual rights and data and isn't selling everything to big tech or other countries. We have that capacity, but we're probably not going to get it because companies are lobbying to hold all of this. It's going to take more people doing lobbying, getting engaged, building the tech in the open, and telling governments what we think to get there. Because I want the positive Star Trek future, not the 100 years of disaster that Star Trek, Gene Roddenberry says, are going to happen before we get there. We have that tech, or we're close. And I don't know if LLMs will ever be good enough to replace even a junior software developer, because they don't think, they just spit out stuff. But companies keep hoping for that, and companies keep trying to do that. And I don't know what our task will be 20 years from now as software developers. But I want to remind everybody of this from a very old training manual, 1979. It's still true. The European Commission could make stewardship of an open source commons by humans into a sustainably funded professional sector whose role is to ensure the safety of a digital society built on that digital commons. Even if governments do not do this, we can do this. And I think that's our responsibility, to keep code that runs the world safe. But it would really help if they'd pay us. Thank you.
That was amazing. Thank you. Let's open the floor to questions. Is there anyone that wants to pose a question?
Hello.
Hello.
Continuing on the topic of AI, there are several resources that go into it. You have money, you have human time. There's also a flow of data. I was wondering what your vision was about how the EU could maintain the supply of data that's necessary to have competent AI, at least how LLMs are currently trained.
Oh gosh, that's a messy question.
And you don't have to fully answer it here if it's just too messy.
I'll give a little example. The UN started funding a project about 10 years ago to archive all open source code that was publicly accessible as part of the creative works of humanity, recognizing that open source is a culturally significant contribution to the world. And so this is part of the UN Heritage Program. That archive, many petabytes compressed and indexed, could be used for training. I don't know if it would, though. And I don't know if that answers your question, because I don't want to get into the specifics of like geopolitics of governments training on their citizens' data. I think that's a nightmare. Right? Training on someone's data without their consent is not great, to put it mildly. Yeah, boxes over here.
Could you explain the term market surveillance in the context of the CRA?
Yes, okay. So this regulation establishes a particular power of a market surveillance authority, but the MSA as a type of entity is created not by the CRA. The CRA is part of a package of related regulations called the New Legislative Framework that includes NIS2, Digital Services Act, Digital Markets Act, Product Liability Directive, and so on. Market Surveillance Authority is a governmentally empowered body in every member state in the European Union who is responsible for ensuring that the products which enter the market are safe. They comply with the law. And handling reports if an individual says, wow, my toaster sprouted legs and tried to attack me. That seems like an unsafe product. You can call a particular agency, a part of your country, and report the toaster. Report the manufacturer. That's what they are. Does that answer your question? Great. Question up front here and back there.
Okay. Thanks for your presentation. Yeah, I have a question related to license, open source licenses. Okay, so how we are going to combine the concept of using the open source license to limit our responsibility, right? And how this gets now combined with the policies from the government, right? So with the European Act. If I'm using a license that basically I'm doing code by myself and I'm going to give this code to the community for free, right? And that was the reason, because these licenses give us this kind of protection in case something goes wrong, right? No one is going to ask you for money or is going to sue you, right? And now you are scaring me because I see this European Act, and it looks like that now we have a level of responsibility as well, right? Based on that. Thank you.
I don't know if, let's see if I can find the right slide. Is it this one? Nope. Went one too far back. Right. So companies have responsibility. Here we go. No, definition of steward. That slide fell off on the cutting room floor. I'm so sorry. Manufacturers have an obligation with attached potential penalties for not complying with the law. Open source developers, individual developers do not. The regulation does not in any way create risk for an individual maintainer contributing code to a project. The only obligation that extends to any entity other than a manufacturer is to an open source steward, which is a legal entity, not a person. So if you happen to also own a nonprofit, you are the sole beneficial owner of this association, and that association stewards open source code, well, again, there's still no penalty. There's no potential fine. There's just an expectation that you maintain the code. Does that sort of alleviate your concern? Yep, got a thumbs up. OK. Is there a question here?
That's unfortunately all the time we have.
OK.
So give a big hand of applause for Eva. Thank you so much. So we will have a closing ceremony in a few minutes. People will start filing in. So if we could leave the front rows, all the plastic seats open for speakers and volunteers. Try to file in the normal cinema seats, please. Please try to fill in the cinema seats. The front row plastic seats are, all the plastic seats are reserved for speakers and volunteers, please. So please try to fill in on the cinema seats. All volunteers, speakers, but also trainers are welcome to sit in the plastic seats here out front.
All right, if the speakers could come behind me here, all the speakers, trainers, MCs, volunteers, please come on stage with me. Yes, absolutely. Okay, now I have a little bit of a problem because all my volunteers are now here, which means I have nobody to take the picture. Who's got a good camera? I see lots of cameras, and you can send them to us, right? Awesome. Okay. I want to thank you all so much for coming. We had a lot of fun doing this. We've been looking forward to it all year. We hope you enjoyed it. Today, the only thing that rests is a little bit of this, and then we're just all going to go downstairs, have a little bit more drinks until 7, just like yesterday. All these rooms, the cinema rooms, will close at 6, but downstairs you can just stay a little bit longer. Rust Week is not just 2 days. It will continue for a few more. We still have the hackathon tomorrow, which will be at Kinopolis. We also have the UnConf and the Rust All Hands, which will both be at the DUS venue, just like last year. Also, just like last year, we will have buses that go there. Please check the schedule for the buses at rustweek.org/bus. Just remember the /bus part, okay? And I think you'll be fine. That's kind of all I had to say logistics-wise. So now I just want to thank some people. I want to thank, of course, our amazing speakers who went on stage here and shared their knowledge with us. I want to thank the workshop trainers. I want to thank I want to thank the MCs. I want to thank all the volunteers in the yellow t-shirts who have been around the whole time. I want to thank our program committee. I want to thank Josina. I don't know if she's here. She's helped us with the organization. I want to thank Lisette. I want to thank Erwin. I want to thank our sponsors. I want to thank Kinepolis. I want to thank Kinley for doing all the technical things around here. And then, of course, Spice for providing all that lovely food and drinks downstairs. And, of course, my fellow organizers, where are they at? There they are. And of course, a very, very big thanks to the Rust community. I want to say, keep being kind, keep being welcoming. You are awesome, and I think this conference shows it. Now, please stay seated for a little bit longer. We're going to take a picture, and then we're all going to sit down for a little bit longer, okay? Can we get some, yeah, pictures? Who's got a good camera? Yeah, yeah. Where's the camera? There's many. Crowdsourced camera, go. This is the open source way of doing things. Now say Ferris. All right, now please go sit down.
And a shout out to Terrence. wait. Hold on. And a shout out to Terrence. This guy has put together the Rust Week opening movies.
right, thank you. That's it. See you later.